A very warm good evening to one and all present here. It gives me immense pleasure to welcome you all to this vibrant 6-day AICT sponsored online faculty development program on high performance computing, transforming research through advanced technology. On behalf of JPR Institute of Technology, I extend a very warm welcome to all the participants and the dignitaries present here. I request Dr. K. Venkatraman, Assistant Professor, Department of CSBS, JPR Institute of Technology, and Dr. S. Bhaskaran, Controller of Examination, JIT, who are also the coordinators of this faculty development program, to welcome all the participants and the dignitaries. Thank you.
Thank you, ma'am. Thank you, sir. Very good evening to everyone. Honorable dignitaries, esteemed colleagues, respected faculty members, and dear participants. Good evening to everyone, and very warm welcome to. Hello, sorry. Very thank you, ma'am. Am I audible?
So you can
Sir, am I
proceed.
audible, sir?
Yes,
Yes, thank you.
proceed. You can
Thank
proceed.
you. Thank you. Honorable dignitaries, esteemed colleagues, respected faculty members, and dear participants, good evening and very warm welcome to each one of you for the Atal Faculty Development Program. It is my profound privilege to address this gathering of distinguished educators and learners as we inaugurate a session dedicated to the advancement of our academic and professional skills. Today, we stand at the threshold of an exceptional opportunity, one that promises to enrich our knowledge, enhance our pedagogical methods, and inspire innovative thinking. The AICT Atal Academy has been a beacon of excellence, championing the cause of continuous learning and professional development. We are immensely grateful for their support and guidance in making this FDP a reality. As we embark on this journey together, let's acknowledge the significance of such development programs in shaping the future of education. The Atal FDP is not just a platform for learning new skills, but also a forum for exchanging ideas, fostering collaboration, and building a community of educators who are committed to excellence in teaching and research. I would like to extend my heartfelt guest speakers who have graciously agreed to share their expertise with us. Your presence here is a source of inspiration and a testament to the collaborative spirit of the academic faculty. Now, may I request our co-coordinator, Bhaskar sir, to proceed and welcome the gathering. Ma'am, over to, we can move ahead with the agenda. Maria, ma'am, you are on mute, ma'am. Maria, ma'am, you are on mute. We can go ahead with the next agenda.
I request our IQAC Director, Dr. Shenbag Ailil, to deliver the special address.
Greetings to all the participants, coordinators, and the chief guest of today, and our beloved principal, sir. It is my honor and privilege to read about the Department of Computer Science Engineering and about the FDP. So, Department of Computer Science and Engineering has been established in the year 2011 with the intake of 60 students and accredited with NBA in the year of 2023. Currently, the total intake has been enhanced to 180 from 2024 onwards. The Computer Science and Engineering Department offers a comprehensive education in AI, machine learning, data science, and analytics. The department features state of the art labs, research centers, and expert faculty with industry experience. The department is well equipped with excellent computing facilities and has highly qualified faculty specialized in area like cloud computing, artificial intelligence, data analytics, and networking, data mining, etc. The objective of the Atal FTP program on high performance computing is to empower educators and researchers with advanced computational skills and knowledge. The initiative aims to bridge the gap between theoretical research and practical applications by providing participants with hands-on experience in HPC tools and techniques. By fostering collaboration among educators, researchers, and industry experts, the FTP aims to create a vibrant community that drives innovation and research excellence. Ultimately, this program aspires to transform research methodologies, enabling participants to utility advanced teaching effectively and contribute to the global knowledge economy. So faculties can gain hands-on experience with the HPC tools and techniques for simulation, modeling, and data analytics, enhancing research capabilities. Participants are also equipped to incorporate HPC concepts into their teachings, forecasting innovations, and interdisciplinary research. And this program will definitely empower faculty to conduct cutting-edge research, securing further for contribution solving global challenges using advanced HPC technologies. So, on behalf of APR Institute of Technology, I congratulate Dr. Venkatraman and Bhaskaran and all the very best to the team. Thank you.
Thank you, ma'am, for your wonderful words. I request our principal, Dr. J. Venugopalakrishnan, to deliver the inaugural address.
Yes.
Yeah. Good evening to everyone. The esteemed guests, distinguished colleagues, and participants hailing from diverse corners of the globe and the honored guest. Good evening, and I am making the special address with this inaugural session of the Atal FTP program. Before we proceed, let us collectively recognize the profound significance of this moment. We are very thankful to our dignitaries, our Honorable Chairman and Managing Director, Dr. N. Mary Wilson, JPR Institute of Technology, Honorable Mrs. Renbagailil, Director IQAC, JPR Institute of Technologies, the Honorable Deans and HODs, and Dr. K. Venkatraman, the coordinator, and Dr. S. Bhaskaran, the coordinator of the Atal FTP, for providing us this opportunity to organize this delightful Atal FTP. And it is very great pleasure and pride that I stand before you today as the principal of this esteemed institution to take off the what promises to be an enlightening and transformative experience for all our participants. And this Atal ACTE, for the past 3 years, they are making this Atal FDP. Then Atal indicates the ACT making the training and learning academy. So this Atal FDP is not only to make the knowledge of the faculties, it should be transformed to the students community. So they are all the young minds to promote what are all they can do in their engineering and the technological development, carrying out in all our areas, and they are supposed to promote. As we gather here today, we are united by a common pursuit, the exchange of knowledge, excellence, and continuous development of our academic powers. This Atal FDP is a testament to our commitment to these ideas, providing a platform for our faculty to enhance the teaching methodologies, research capabilities, and to stay abreast of the latest advancement in the respective fields. This Atal Academy has been instrumental in fostering the innovation and the research among the faculty of the technical institution. It is an honor for our institution to collaborate with Atal, and I am confident that this FDP will serve as a catalyst for sparking new ideas, fostering collaborations, and encouraging a culture of lifelong learning with some entrepreneurs also. Over the course of this program, you will have the opportunity to engage the distinguished experts, participate in hands-on workshops, and discussions that challenge conventional thinking. I urge you all to make the most of this opportunity to question, we explore, and to push the boundaries of what you know. As educators, we bear the responsibility of not just imparting knowledge, but also of inspiring our students to become thinkers, innovators, and leaders of tomorrow. The skills and insights you gain from this FDP will in turn be passed on to your students, creating a ripple effect that will extend far beyond the walls of our classroom. Finally, This is an opportunity, time for me to declare the official opening of the FTP, the titled High Performance Computing, Transforming Research Through Advanced Technology. And I wish all the 6 fruitful days of interesting and beneficial program. I'm making all the dignitaries, the speakers, or the resource person. They are accepting our invitation, and also the external faculties and our internal faculties, all. We are making a warm welcome you again. Thank you.
Thank you, sir, for your words of encouragement. Without much ado, it gives me immense pleasure to welcome our chief speaker, Dr. Parthasarathy. Dr. R. Parthasarathy is currently serving as an Associate Dean and Assistant Professor in the Department of Electronics and Communication Engineering at National Institute of Technology, Tiruchirappalli. With a strong academic foundation, he earned his PhD in RF and Microwave Engineering from Anna University, Chennai in 2021. Dr. R. Parthasarathy's research expertise spans a wide range of cutting-edge areas, including microwave antenna design for diverse wireless applications, 5G wave technologies wideband and super wideband applications, and electromagnetic interface suppression in low-profile antennas. This work on intelligent reconfigurable surfaces, IRS-based MIMO antennas, and frequency selective surfaces demonstrate his visionary approach to solving complex engineering challenges. Today, we are privileged to have Dr. Parthasarathy to share his insights and expertise with us. Please join me in extending a warm welcome to Dr. R. Parthasarathy. Welcome, sir, and the session is now.
Yes. Am I audible, ma'am? Am I audible?
Yes, sir. Yes, sir.
You are audible, sir.
I think someone is not
Thank
unmuted.
you.
Can we give the instruction who's unmuted? Yes, thank you so much. Let me start the session. Thank you for giving a wonderful introduction about the Atal FTP and the research session. People are covered clearly in each and every one. Once again, thank to give an opportunity to talk about today. Let me present this slide. It is visible, sir? It is visible?
It is loading, sir. It is loading, sir. Sir, Kripakaran, sir, could you please go on mute, please? Kripakaran, sir?
Yes, sir.
Please go on mute, sir, please, sir.
Yes, sir.
I request you to go on mute, sir.
Sir?
It seems that I request you to be on mute, sir. It seems.
Okay.
Okay, sir. Please, sir. Thank
My
you, sir.
slides are visible, sir. I have shared
Yes, sir.
this.
Yes, sir. Now your screen is visible, sir. Yes,
Okay.
sir.
I am scrolling. Kindly help me whether it is moving or not. I'm scrolling.
Sir,
Now I
I
am
am
in
not able to
outline.
see your
Yes.
slides. Only the screen is coming yet.
No. I have shared. That's what I'm asking.
Okay.
Now I'm moving these slides. Can you able to see? No.
No, it
sir,
is
I
not
can't.
visible.
Wait.
No, sir, not visible.
Wait.
Only your screen is visible.
Again, I'll
Slides are not
share.
visible.
Now it is possible, sir.
No, it is not visible.
No, I shared, sir. I
Yes.
shared the entire
Yes, sir.
screen.
Yes, sir. Yes, sir.
I'm scrolling. Can
Yes,
you
now
able
we
to see that? I'm scrolling. Whether
Yes,
it is
sir.
moving.
Yes, sir. Yes, sir. Yes, sir.
It's
Yes.
going right.
yes.
I'm moving to computing power of single CPU chip.
Yes, sir. Yes, sir. We can see, sir.
Yes, it's
Yes.
moving. Okay. Thank you for the confirmation. Right. Yeah. Very good afternoon to one and all. Sorry. Very good evening to one and all present in the group. Myself, Parthasarathy, working as an assistant professor in the Department of Electronics and Communication Engineering. Thank you very much for giving this opportunity to talk about the cutting edge topic of high performance computing. Because when you go to talk about any processing, it may be a electronics engineer, computer science engineer, anywhere, the high performance computing is very, very important. So I wanted to appreciate the Atal organizers, because they have chosen this topic and then they are giving a lot of literatures. I have seen the arrangement of
Excuse
the
me, sir. Excuse me,
yes,
sir.
yes, yes.
Sir, it is
Yes,
not
yes.
visible. Your slide is not visible.
Now it is visible, sir.
No, it is only coming over the doctor written over there, Parsati, sir. So slide is not
Yes,
visible.
I didn't move, sir. I didn't move. I just am talking about.
Okay.
Can you see the outline now?
No, outline is not coming over there.
Yes, sir. Yes, sir. Outline. See.
Outline is coming, right? Just I'm scrolling. No, I just I'm giving the introduction. I'm not moving the slides. That's why I think so. You're not getting. Now I'm in third slide. Can you able to see, ma'am? I'm in third slide. Can you able
Yes,
to
sir.
see?
Yes, sir. Yes, sir.
Now I'm fourth slide. Can you able to
Yes, sir.
see?
Yes,
Fine.
yes.
Okay.
Yes.
Sir, kindly check your side, sir. I think so. You have some issue in your system. Fine. Okay. Okay. So the high performance computing is very much needed. Those who are doing a high nodes research, the people wanted to do a research, and then they wanted to simulate irrespective of any research. People wanted to do the very first step is simulation, right? A lot of tools are available in each domain, each department. So if you wanted to run that high package node systems, we need a high performance system, right? So that is the reason why this topic is very much important. Okay. So when you talk about introduction to high performance computing, this entire lecture, I'm planning to give what do you say, a very basic concepts behind this HPC. Okay. I'm not talking much more on advanced topics, because the people who are doing research, they may not be useful this. I wanted to give some basic information regarding this HPC. What is HPC? The people, after the end of the section, people may understand clearly about what is HPC. Okay, so that is the ultimate aim of this topic is coined today. So introduction to high performance computing. So the outline of this today's presentation is goes to introduction to what is HPC, what is history and the evolution of HPC, where it is being started, and what is the aim of HPC coined in the history of when they started to do the supercomputing technology. Okay. The next one is applications of HPC. What are the applications are available? Anyway, one more slide is there. There I will show you stage-wise what are the applications. Okay, industry, academic, agriculture, research, in different areas how the HPC will be applied, and what is the main importance of this HPC. Okay, so that also we can came to know. And key components and architecture. When you're going to talk about HPC, what are the components and architectures are needed? The people who want to do a research, are you the people who wanted to know about what is HPC? So that you will detail, you will see key components and architectures. And then parallel and distributed computing. What is meant by parallel and distributed computing? We know, I think people may know about what is parallel and serial computing, because a lot of subjects and concepts we have seen. How it is going to differ your parallel and distributed computing, that is also a very important topic. So that you will see. And then program modes, what are the programming modes are there? And this is a very important one, challenges and trends. What are the challenges are there? See, really I wanted to work on in HPC. What are the real challenges? When you're going to talk about in terms of system, it's possible. But if you're going to implement a hardware, you want to take a very high level of tightly packed VLSI systems. You want to take a tape out either an analog VLSI or digital VLSI. What are the challenges are there? Because it's very important, right? People they can talk in system level, in software level, this is working that and this and that. But if you're going to take it as a hardware, if you're going to implement in any one of the supercomputing and you wanted to check it with the performance of the system, it is very, very important, right? The people wanted to know about what is actually happening in the real world after you are implementing any concepts or software or hardware, whether it is capable or not, right? So that is one of the challenge. I can say my experience, the next challenge is the people who are introducing a new technology in terms of software, AI and ML, but the hardware should be capable to take care of that, right? So you need to think about what is the hardware cost also, right? So that's very important, right? Because if the hardware cost is very high, it is not possible to use everyone, right? It is very difficult to use in the commercial applications, right? So that is the other challenge I can say. And then case studies. What are the case studies are there? In future, where HPC going to be, and the conclusion of this particular presentation. This is the outline of today's presentation I am planning to give, right? So whenever you have a doubt, you stop me, right? No need to wait for the end of the presentation. Wherever you have a doubts, kindly stop me. I'm ready to answer your doubts. Then I will go to the next slides. Okay, right. Computing power of a single CPU chip, right? So before going to this topic, I wanted to talk about Moore's law. What is Moore's law? People know about what is Moore's law? What's Moore's law? Why he has given approximately every 2 years? What's the meaning of Moore's law? Have you any doubt? Have any idea about Moore's law? People studied about digital electronics. They can answer this question. I think so. Yes. What's Moore's law? Anybody? Anybody in the group? What's the importance of Moore's law? OE has coined like this. Not only the computing power of the CPU. See what he said. He's a co-founder of Intel. In 1965, he had given the statement. Not only the computing power should be doubled. See, I am simulating some software. I'm working something. It takes 1 hour. After 2 years, the same work has to be done within half an hour. That is Moore's law. It's a vision. It's not a law, or it's not an enforcement to the people who are working in this particular domain. He has given a vision statement. If you do in that particular manner, you are going in a proper technology development mode, route. Okay, in a route map, you can say that. Okay, so what he said, the power of the computing power of the CPU doubles after every 2 years. It's not approximately every 2 years. Most of the books it's given, but he has given 18 months. Every 18 months once, the actual size of the chip should be half of the size. Let's say the size of the chip is 1 centimeter cross 1 centimeter. After 18 months, the same chip has to work, but the size should be 0.5 centimeter cross 0.5 centimeter. So the size of the chip should be half of that every 18 months, and the performance of the chip should be double every 18 months. That is the actual law of Moore's, what he is trying to explain to us. Okay, so he is a co-founder of Intel. In 1965, he has given the statement, and based on this statement, if you follow, what will happen? Your technology is going to be huge. That's a graph you can see in 2011 up to 2011. I have taken from the textbook this graph. Okay, so it will be very helpful to find out what is he is trying to explain. In modern developments, what do you have to do? You have to go for multi-core processors. Have become the key innovation to sustain. Okay, the people may know about actually what is multi-core processors. What is processor? I wanted to ask a very basic question, but I forgot to ask that question. Actually, I planned to ask this question initially when I started my literature. People know about very well microprocessor, isn't it? Everyone will know microprocessor. Yes or no? People know microprocessors. Yes or no? Say yes or no. Someone at least 1 or 2.
Yes, sir. Yes, sir.
Yes,
People know
yes,
very well.
Yes,
What
sir.
is nanoprocessor? A separate department itself, it is there in Anna University CEG campus. Nanoprocessor technology. Nanotechnology is a MTech. MTech in nanotechnology is there. What is the difference between this microprocessor and nanoprocessor? Have any doubt? People have any? Can you say the difference? Anyone in the group? Because we are all someone is saying yes. Yes.
Nanoprocessor is small in size than the
No.
and the computing power. Yes.
No. I need a much good answer of this. What is the basic difference between microprocessor and nanoprocessor? Anyone in the group? That's fine.
Sir, the transistor density will be very high in nanoprocessors compared to microprocessors, sir.
Yes, exactly. Why it is very high dense in nanoprocessor, it is accepted, but microprocessor is not accepted?
Because design itself like that, sir. They use advanced transistor technology, sir.
Yes.
They go for advanced transistor technology.
If you go to talk about, yes, exactly, sir, exactly. If you go to talk about microprocessor, the transistor, when you say transistor, people know very well about BJT, isn't it? you know, emitter, base, collector, right? In the 3 terminal, emitter terminal have a high current compared to other 2 terminals. Whenever the conductor carries a current, it flows a magnetic field, right? Whenever the conductor, see, this is the conductor which carries the current. Okay, if there is carries a current, what will happen? It creates a magnetic field like this. So if you're going to keep another transistor very close to this, what will happen? This line and this line going to be coupled and it will get short circuited. So what I want to do, I have to make an emitter here, and then the another emitter should be here. The distance between the 2 emitter terminals, the transistor 2 emitter terminals are 1 micrometer. The distance between the 2 emitter terminals are 1 micrometer. It's called microprocessor. So when you say processor, lakhs of transistors are there. The distance between the adjacent transistors are, the distance is 1 micrometer. If you go below 1 micrometer, what will happen? The magnetic field which is generated due to the current flow in the conductor and the magnetic field which is generated due to the current flow in the conductor will be interfered to each other. If it is interfered, it will create a electromagnetic interference, right? So it will act as a short circuit. The entire processor will be worn out. So that is the reason the microprocessor, the distance is very high. But in nanoprocessor, what they did, instead of orientation going like this, they changed the orientation of the magnetic field like this. So in nanoprocessor, the magnetic field flows in the elliptical form of along the line. So what will happen? There is a space. So if you go like this, there is a space between this two things. So they reduce the distance between the 2 emitters. So now the distance between these two is 1 nanometer. So that is the reason it's called nanoprocessor and this is called microprocessor, right? So any processor which carries the active elements, n number of active elements, that is lakhs of transistors are arranged, formed as array, which act as a transistors. The distance between the 2 transistors are 1 micrometer. Why it is micrometer, I explained now. Then it's called as a microprocessor. When it goes to the distance in the 2 transistor terminals are 1 nanometer, then the processor is called a nanoprocessor. Why I want to ask this question is, based on this question only, we are going to talk about multi-core processors. Okay, modern development. Same way, same nanoprocessor, instead of going a single layer, the top of that another layer will be there, the top of that another layer will be there. It's called a multi-core processor, right? But each layers will not get interference to like each other, like that it has been made. Okay, so that is a key innovation to sustain the performance improvement. If you want to improve the performance, you want to increase the speed, you want to increase the processing speed, we wanted to do some other method. So what they did after the nanoprocessor single layer invention, they went for the multi-layer, right? So if you're going to take your mobile phone, it's a 7 layers. Any mobile phone which is not working, you just see it and you can see 7 layers. 7 layers are tightly packed to each other and they act as a single board. If you take your color TV, not this kind, nowadays what are the TV you have, you go picture size TV, you can see that there is a board. The board will have 2 layers. It's not a multi-core because more than 2 layers are there. It's called a multi-core processor or multi-layer processor. It's a multi-core processor. When you say multi-core, more than 2 layers are tightly packed to perform the high speed and multi-core handling range, right? So that is the reason why we wanted for the modern development. So in the modern development, what they started the multi-core processing technique, and then instead of increasing the clock speed, because when you keep on increasing the clock speed, what will happen? What will happen when you keep on increasing the clock speed of the processor? What will happen? People know, I think. The clock speed is keep on increasing in terms of some megahertz to gigahertz to some terahertz. What will happen? Yes. What will happen?
The number of instructions you can perform that increases.
Yeah, yes, it will keep on increasing. That is the reason why we should not increase the clock speed. So instead of increasing the clock speed, they concentrated in the multi-core processing. That is the range using a single CPU. How can you increase the computing power, right? So that is the main idea behind this. I wanted to go next one. Right now here, why computer cluster? What's the need of clusters, right? Why I wanted to go for clusters? Like segregating the job, right? We wanted to segregate the job is nothing but a cluster, right? So drawbacks of increasing the CPU clock frequency. Here, what ma'am has given, the same answer which is given here, CPU clock frequency. When you're increasing the CPU clock frequency, is nothing but a processor clock frequency. Electric power consumption is proportional to the cubic of CPU clock frequency, right? So the power consumption should be very, very high when you're going to keep on increasing the clock frequency. What will happen if the power consumption is high? Not only the power efficiency is going to be lost, also your processor get heated. Processing heat is going to be very high. When it is going to be very high, after some particular time, you can't give 3 years or 5 years warranty of any supercomputer, it will start to burn out, right? So that is the main reason. It generates more heat. Even though you have a heat sink in your processor, top of the processor, it will not allow you to perform further, right? So that is the main reason why you should not increase the clock frequency. Also, what ma'am has given the input, that is also correct. In number of instructions should be very high. Okay, so a drawback of increasing the number of cores within a one CPU chip, difficult to heat dissipate. In a single chip, if you're going to do all those things, it is very, very difficult to heat you because you are doing a very high computational performance, right? You want to do high computational in a single core chip. Definitely, it is very difficult to follow it. So that is the reason you should not increase the CPU clock frequency after some certain range of level. Okay. So computer clusters connect many computers with a high speed network. So what we are doing, we are taking the same work, we are taking the work, we are segregating into a number of elements. It's called as a clusters. After all the individual works are done, we are collecting together. It's nothing but a computer cluster, right? So what you are doing, connect many computers with high speed networks. Currently, computer clusters is the best solution. What way of connection you will use to increase the speed of the networks? What I said, I am taking the work, I am dividing into n number, let's say 4 number. After each work is done in 4 nodes, just I am connecting to here with the high speed network, right? What is a high speed network cable you will use here? The only cable is optical cable, because optical cable have a huge bandwidth compared to all other cable. All other electrical cable compared to all other electrical cable, you have a huge bandwidth in the optical cable, right? The bandwidth is infinity if you're going to talk about in the case of IDM, right? They found the invention has been done, and then a lot of research work has done in the optical fiber, and then they say that optical fiber have a huge bandwidth. The meaning of huge bandwidth, what they're saying, at a time, 2 crores of people can able to talk without getting interference. 2 crores of people. But if we don't have a system to test that, more than 2 crores of people can able to talk at a time or not. That is a huge bandwidth, because a lot of variety of optical fibers are there, single mode, multi-mode, graded. So a lot of fiber methods are there. That they will use if you want to connect like this, and you wanted to, or you don't want the delay over here. We wanted to use the high-speed network, the high-speed networks which is connected with the help of optical fiber. Okay. So currently, computer cluster is the best solution to scale up computer power, right? So when you want to increase the computer power, right, the only method is computer cluster. The computer cluster is a very useful, best solution to enhance the power. Okay, so consequently, software or programs need to be designed in the manner of parallel computing. So we need a proper computer software, right, using to increase the parallel computing. Anyway, we'll see one by one what is parallel computing, what they are trying to explain to us. Okay, right. So the basic structure of the computer cluster. When you're going to talk about what is the basic structure of the cluster, right? So here, cluster is a collection of many computers, as I said, are nodes. Rack is the closest to an old branch. Anyway, I am giving a basic information. People may know about the subject. They can think that this is redundant data. But anyway, introduction to HPC, that's why I'm giving each and every point, and I prepared to give for a basic learners. Okay, right? So rack is the closest to hold bunch of nodes. Okay, node is nothing but a computer with a processor, memory, and a hard disk, like your server. Okay, in your college side, you can see the servers, and you can see a number of rackers. Each racker are connected. It's nothing but a single clusters or nodes. Okay. And core or processor, one actual processing unit will be there. Network switching is there. Storage system is needed. Power system, cooling fan. If you're going to talk about a basic structure of computer cluster, it does not have a monitor. It does not have an individual way to control that. But collectively, it is controlled by a person, right? So all those things, integrating of all those things, we can call a basic structure of cluster. I'm not saying this is cluster. When you talk about a cluster, for using HPC performance, then we need these are the minimum requirement to say that the particular system become a computer cluster, right? So that is a point I have given over here. And then what is HPC? This is the very first point I'm moving. What is HPC? HPC uses a supercomputers. Whenever the term supercomputer has come into the picture, please remember the two agenda, two pramastra. One is the computer processor made up of nanotechnology, not microprocessor. Please remember that. Most of the people will say wrong. Okay, supercomputer. Whenever I'm going for some what do you say, faculty recruitment, the people who are coming and presenting, they are not aware about that, right? So that's a big question I will ask whenever any faculty those are coming for giving the presentation for the teaching job. They have to be very clear about that. Okay, supercomputer nowadays maybe in older stages they will use microprocessor. Nowadays they are using nanoprocessor as a supercomputers. The second one, when you say nanoprocessor, yes. Hello. Somebody is talking. Somebody wanted to something say.
தமிழ்ல தெரிஞ்சு சொல்லுங்க, இங்கிலீஷ்ல சொல்லி ஆகணும்.
Am I audible, sir? Hello. May audible,
Yes, sir.
May audible?
Audible,
Yes, sir.
but,
Yes, sir.
but
Yes, sir.
presentation is off.
No, I didn't do anything. Now it is visible. Shall I continue, sir?
Yes, sir. Visible.
Yes.
Okay.
Yes, sir.
So,
Yes,
Visible
sir.
now.
Yes. Thank you. So HPC uses the supercomputer. As I said, when you say supercomputer, it consists of number of clusters, right? Minimum 2 to 3 clusters will be there. So we called a multi-core processing system. Okay, and then all the processors are made up of nanoprocessor. Okay, and then you need a parallel processing. Integration of all those things, you can solve the complex computational problems. What is this? Research area, people are running for 5 years, 8 years, 1 hour, 1 day, right? We wanted to run all those things. You need a huge computational data sets, right? We wanted to run all those things. You need a supercomputer with a parallel processing technology. That is nothing but your HPC. So HPC is the basic supercomputer node which is used to solve the complex computation, not for the simple problem, complex computational problems. So people are working for wireless communication, people are working for mathematical analysis, people are working for a lot of node analysis and mesh analysis. Those areas, this kind of supercomputers are needed. That's one of the application. You can see what are the applications. Next point I given: applications in scientific research, engineering, large scale and data analysis. These are the different areas of applications wherever you wanted. These are the applications. Anyway, we'll see one by one what are the applications. And key features are the speed will be enhanced and scalability will be very high and efficiency is going to be very high. Okay, so all those things are improved by using the HPC. There's a main area behind the HPC. Okay, right. We'll go history of HPC in play. Early computing, the main frames and the development of parallel algorithms are 1980, emergence in the vector processors. People know about what is vector processor. What is vector? What is vector? Have any idea about what is vector? No, you know about what is vector, then I can you can say that what is vector processor.
Sir, actually it is present in the supercomputer sir.
Fine. I am not asking in terms of supercomputer. Just I am asking the term of vector. What you are talking about vector? See, in mathematics also where people are know about scalar and vector, right? What is vector? What is scalar? How can you explain to someone new to
magnitude and direction? It has both magnitude and direction. Means
in other way, how can you explain, ma'am? Vector and scalar. The guy is new to the scalar and vector. How can you say that?
Scalar quantity means only it denotes the magnitude. Vector means it denotes both magnitude and direction.
Okay. Any another word, ma'am? Any other explanation? Any other way to explain what is vector? Till the end of lifetime, you should not forget this vector. What is vector? Can you use any other word, different word of what is vector?
Sir, a magnitude on
Yeah,
phase,
what you
sir.
said, that's correct. Sorry.
Magnitude on phase.
Correct. Already ma'am said, sir, I accept it. Apart from that, what you are understanding from this? Apart from this two terminology, what you are understanding from vector compared to scalar?
Vector, it's a cross product.
No. There are two products will be there in vector. Dot product, cross product, both are there. I'm not going to the classification of vector. See, the other term is, when you say vector, you are getting more detail about that quantity. See, I am saying I am going my negative. That is my scalar. From where to where I am going, that is my vector. So what is the meaning? I am giving you more information about that particular guy. I am giving you more information about the particular quantity. Similarly, whenever I have a vector processor, I am giving a clear picture about which part of the processor is working this, which part of the process is doing a pipeline, which part of the process is doing other work, which part of the processor is doing the ordinary work, which part of the processor which is working for OS running. So the vector processor is the first processor which has been introduced in 1980. Before that, we don't have any clear picture about this, because we know now vector processor. Because of the vector processor only, you can see in your system which in your RAM or in your processor, what is the percentage of this particular processor taking of the doing this work. Remaining, what is the percentage is taking because of the vector processor. Now, what are the processor you are seeing in your system? Everything is vector processor. If the vector processor is not there, you can't able to find out which part of the processor is working for the particular software. Right? So vector is nothing but giving additional information about the particular quantity. That's the main meaning of what is vector. When you say vector, it gives the additional information about the particular signal, particular information, particular quantity, anything else, right? So the emergency of vector processor has been introduced in 1980. Before that, there is no any vector processor. The processor will be there. You can't say that, you can't in detail analyze which part of the processor is working, why it is hanging, whether the processor is good or not to do the particular job. You don't have any idea about that, right? So that has been initially founded with the help of vector processor. Now I can say proudly all the processors, what are the processors in your mobile phone, iPad, laptop, everywhere, all the processors are vector processors. That's why you can able to find out whether this processor is enough to run this, or whether this RAM is sufficient, or this RAM is more than the processor capacity. Everything we can able to find out with the help of this vector processor, right? Okay, right. So that is the reason why I asked this question. The next one is, in 2000s, the growth of distributed and cluster computing has came. Already we have discussed what is cluster computing. I given the input, and then distributed means we are segregating the job in a different nodes and asking each node to perform, and collectively the main node will collect all the information, and based on that the main node will give the inputs, right? So it's called nothing but a distributed. If this is going to be started initial stage of 2K, right? In 2K, these have been started. The growth of distributed and cluster computers came in order to enhance the computing facility further, right? And presently, the word of present is 2011, not 2024, because I have taken this is the book which has been wrote in 2011, and based on that input I have prepared this PPT. This is 2011 input. Accelerate computer and quantum integration, right? So in 2011, this is a method that have been used. In 2024, the people who are working in research and they're doing the HPC research, they may know about that, because I'm not aware about that, what is actually happening in HPC in 2024. Okay, you have to do the literature. People, you can get a lot of techniques and a lot of methods, and a lot of softwares has been came to enhance and reducing the heat and increasing the efficiency of the clusters. Each and every clusters, a lot of methods are came. But anyway, you do a literature, you came to know what is actually happening in 2024. But this is a presentation I'm giving based on the data of 2011. Okay, so extra scale computing and quantum integration has came into the picture when in 2020 to enhance the performance of HPC further. This is a history, just I wanted to show you. I have taken this PPT. Okay. The next one is why HPC. People know about that, right? The main reason of why HPC: solve the problem that requires a massive computational power. We know that this is the what I can say generic and traditional reason why your HPC is needed. People, a lot of people know, maximum all the people will know about why HPC is massive computational power. And the next one, accelerate research and innovation. I can't wait for each and every step result of research one day or 2 days. I want it within 10 minutes. I want it within half an hour. Then the acceleration speed of the research and the number of publications will be increased if I have a very good computational system. Massive system is there. I can easily do it, right? So the innovation will be increased exponentially if I have a very good HPC system, right? So that is the reason. Then the next point is very important. Enable real-time processing for applications like weather, right? Forecasting and AI. Based on this only, you can be able to remember. If you go and see 15 or 20 years back, you can't able to predict exactly what time, what day the cyclone will be, which area will be this much rain and this much temperature, humidity. You can't find it, isn't it? Now they are predicting exactly within an hour. They are saying that within half an hour or 1 hour, they are saying that next day, next month, next week, right? They're predicting 1 week before, and exactly they are saying which area it's going to be crossed the cyclone center part and which part have huge rainfall. Everything they are predicting, right? Because of with the help of weather predicting forecast. Not only about the computer, I'm talking about the technology has been improved in the forecast department. Okay, so that is the one of the main advantage, right? When you're going to talk about why HPC, these are the part. Anyway, people may not be see this. I will share if you wanted this PPT also. People can be able to understand what is I'm trying to explain here. Okay, so the clusters are there. Then you have a core, right? In the clusters, these are the parts which is available. The main way I can say HPC midway and the HPC hardware, right? As I said, you can anytime you can change or you can implement a new software over here, but you need to know about whether this hardware is enough to take care of this particular platform, right? So if you want to integrate this platform in your HPC, you should be aware about before you are implementing your platform into the your HPC. You should be very much clear about how much parallel computing is possible. Just a minute. Right, how long it will work and what is the amount of power it will consume and how what is the heat sink capacity. All the hardware component related issues you need to be aware about that before you're going to implementing the your platform into that to perform your complex computational issues. Okay. How to measure the computer performance? Maybe know about that. I think people may clearly know about what is this flops, right? What is this flops are? No, you know it. Anyway, that's why I'm not explaining more that. And the third term clock cycle is a pre-second is known as a clock frequency, typically 2 to 3 gigahertz, right? Now the processor has new processor came 4.7 gigahertz. The clock frequency of 4.7 gigahertz, a new one. And most of the people are purchasing for the research purpose. In our institute also, they purchase a lot of systems processor based on this frequency range. It works very high, and then the performance is very good. In Dell, they have been introduced this 4.7 gigahertz clock frequency of processor. But typically, most of the workstations in all the private and government institutions, they are using 2 to 3, 2.7, 2.4 is a popular one. So these are different clock frequency signals that they are using to perform their complex issues to solve the research problems. Okay. The fourth term is flops per cycle. How many flops floating point operations are done in one clock cycle? Okay, so that is also the third part talks about. And the typical values of Intel Xeon processor, you can see these are the different types of flops. You can see this is the generic data. Okay, so the generic data about how to perform the basic measurement of the computer performance, how the performance is going to be. Okay. So the key components of HPC, I'm showing you only the basic key components. I'm not going in detail in terms of hardware as well as the software. Okay, just I'm showing the key components of the HPC compute. You need a CPU. The next one is very important. GPU is needed, and then accelerators are needed. These accelerators will identify which part of the processor is free and where we can give a high work to the processor to perform, and where the other part of the work has been done. So everything is going to be communicated and synchronized between the two nodes with the help of accelerators. Okay, so the accelerator is the other important component in the HPC. Then storage, right? The next one is very important, storage. Like how you can say in wireless communication there is a bandwidth issue. Similarly, the storage issue will come into the picture, right? Storage is a very important one.
Hello.
Yes.
Hello.
Yes, sir.
Sir, can you give the example of accelerator? Accelerator, can you give example of accelerator?
What kind of examples you are expecting? I didn't get you what you are expecting.
Like GPU and CPU, can you explain what is the actually accelerator does? Because CPU performance for the computation, GPU for the graphic processing unit. Then what is the use
but here when you're going to talk about yes. See, when you're going to talk about CPU, it's not a single node, a single core. It's a multi-core and multi-layer. Between this multi-core and multi-layer, you wanted to share your data, because the data has been the work has been divided into n number. You wanted to share or you wanted to combine all those things. We need accelerators. The accelerator is a sensor, or accelerator is a device which is used to measure where the job is done, where the job is going to be done. The pipeline has been properly channelized to the CPU and GPU to perform the particular work. So that is the main aim of accelerator. I cannot say what are the types of accelerators are there nowadays.
Okay, so the GPU, there are different kind of GPU. Is there any other kind of accelerator? Accelerator is only hardware, or it is kind of software?
No, it's a combination of hardware and software. It's not only for hardware. It's not hardware, but the hardware is, see, the hardware, how it's performing based on the software. The software will give an instruction to the accelerators. Which core, say, let's say, if I have a 8 core, okay, if I have a 8 or 4 cores are there, core 1, core 2, core 3, core 4. If this work is going to be done within a fraction of a second, the core 1 process of work is going to be done. The next work I can give with the help of this accelerator will be here, which will be sensing when it is going to be completed is estimated time. Whether how long it will take, whether it is completed or not. So it will keep on sense all the nodes where the core is going to be free, where the core is free currently. The accelerator will sense and the instruction will be sent to the main core. The core will exactly allot the data, allot the work to the particular node, which will be done with the help of accelerators. If the accelerators are not active, not sensing properly, what will happen? After the work is going to be done, again it will wait some amount of time. It's called fraction time amount, timeout time. Right? So this timeout will increase the computational time. We wanted to reduce the computational time. We wanted to do this. So the accelerators are very important to allot the work where the cores have been done the work or not. It will continuously sensing each and every core which is present in the processor. The processor has been divided into a number. So each core how it performs. Maybe some cores in 7th layer, some cores in 6th layer. So it's a multi-core, multi-layer. So which layer, which core, where it is working, where it is free, everything is going to be controlled with the help of accelerator. That's why it comes under your computing. So when you say computing, combination of EPUs, GPUs, and accelerators are very important when you want to complete your work within a given time, or you want to increase the time period of the computational issue. Okay? I think I answered your question. I think so.
Okay, sir. Okay, thank you, sir.
Yes.
Thank you, sir.
Yes, thank you. Okay. So the next one is going to be storage. When you're going to talk about storage, high-speed data storage system is very important, because you have to store more data and the speed should be very high when you want to take it out or when you want to put there, right? So we need a high-speed data storage system is needed when you talk about HPC. Like how we are talking about computing, the same way the storage also we need a huge. And then networking, as I said already, high bandwidth, or also I can say wide bandwidth. Wide bandwidth. The other term we can say wide bandwidth. Okay, wide bandwidth also needed when you want to interconnect the nodes, interconnect between the computing and storage device, interconnecting between the other nodes, interconnect between the internet. Everywhere you need a cable, right? You need a networking. If the networking is not good, even though you have a very high computing facility, very high storage facility, If the networking is not good, then automatically your system will become useless, right? So we need to be take care of the network. That's why people are doing studying separate subject itself, computer networking. In UG, computer science and CE, ECE, electrical department, IT, all the people are studying this subject. This is the one of the very important subject as a communication engineer or a processor engineer or a HPC processor engineer or software engineer. Anybody, they have to be very much clear about this. What is networking, and then computer networks is very, very important, right? So if you are designing all these three parameters, I'm talking about only in terms of computing, storage, and networking, then I can say this system is HPC. These are main key components. When you say HPC, this component should be there. If it is not there, I can't say that is HPC system, right? So that is the main key components which is present here. The continuation, already I discussed about these things. The same way they're saying that networking gateway should be there. The local network, each and every one node should be are connected together. Then login nodes will be there, and boost servers and management nodes will be there. All those things are combined together. We can't call it as the HPC. The structure of this arrangement will vary. The structure of this arrangement will vary based on the applications, based on the number of nodes, based on the computing problem which you are giving to the system. Right, the capacity of the system will vary and based on your performance, right? So for an example, I am giving this network to understand what is actually components which is present in the HPC in detail, right? This is the key components and this is the distributed components which is present in the HPC, right? And then this is a very important one, HPC software stack. Okay, so what are the HPC program tools are available? These are the main tool. And this data has been taken up to 2015. I don't know what are the tools which have been after came, because the textbook whatever I have taken, that is 2015. Up to 2015, these are the HPC performing tool which will be putting a hand together to the hardware to enhance the performance of computing. You want to increase the computing of the particular supercomputer. These are the tools are helpful to enhance the performance of the particular supercomputer, right? And the operating system, you know it. Operating systems are main Linux only. The most of the supercomputer they will use Linux, because Linux will have a what is the main advantage of Linux compared to other OS? Have any idea? Yes. Have any idea? What's the main advantage of Linux? Why you want to use this?
So it is a very large multi-operating system, sir. It can take more load, sir, compared to other multi-operating systems, sir.
Why? Why it's taking more core? What is actually happening in the Linux?
Because of its microkernel architecture itself, like that, designed like that.
Yes, that is the advantage. That is the reason Linux will have a huge impact, especially in terms of when you're going to design a HPC supercomputers compared to your PCs. Okay, so that is the reason. So anyway, just I'm giving the three clusters of HPC. What are this? And middleware is nothing but applications and management. What are the applications and managements are needed when you want to properly tune your HPC to perform? Okay, and single CPU systems. When you go into single CPU systems, as I already discussed about this, this is nothing but a simple PC. What PC you have in your home? It's simple PC. There is no any core or something else. As it is works, it's nothing but a simple PC system, CPU system. When you go to talk about simple CPU, these are the characters. Can run single stream code only. At a time, only one code it will run, and it have a ALU, and it have a clock frequency only. There is no any other way, because you don't have a distributed system. You don't have a multi-node or core or multi-layer. What will happen? It will work. That is the only way you want to increase the speed. Clock frequency has to increase. That is also not possible beyond some certain range, because the system and processor will not helpful to work. Okay, making use of pipeline method. You know what is a pipeline method, right? So using pipeline, you can enhance and improve the compilers. These are the different methods. You can increase the performance, right, by using the single CPU system. But this is not preferable for industry applications. For the academic applications, they can use that to some certain range of problems, statements, computational issues, you can't use this, but some range somewhere you can use this, like a mini HPC. Okay, and the challenges are limit to each these techniques. There are limits to each. That's what I said. Clock frequency you can't increase. You cannot increase certain range. You cannot do for the pipeline alone, because pipeline will fill. Then again it will create the hanging method, right? That you can't go for more improvement in the compiler. You can't. Just a minute. Sorry. So you cannot increase the ALU, right? ALU also you can't go more than that. So that is the these are the challenges while improving the performance. The performance also you can increase, but certain range you cannot able to increase the performance. Then the solution is parallel computing provides a relief by enabling simulations execution of multiple tasks. So that is the only solution. You have to go for the parallel computing first. Now I am going to start what is parallel computing. What is parallel computing? Divide the task into a smaller subtasks. Okay, process subtask simultaneously, reduce the computation time significantly. Right? The work has been divided into n number of parts. Each node will perform the works and combine it together. It will it will automatically reduce your computation time period. Okay, so that is the main aim of the parallel computing. What you want to do? See the problem, which is divided into n number of instructions, which is given to 3 CPU, and each performance once is done, then it is going to be combined together, right? So it's something about parallel computing. Why use parallel computing? As we already discussed, what is the use of parallel computing? Limitations of single CPU systems. Sequential systems are slow. That's the first reason. Then calculation may take days. That's what I said. It may take days, months, weeks, or years, right? So that is another one. Sequential systems are small, and the large data sets may not fit into the memory. That is another important limitation of single CPU. That is the reason why we are moving to the parallel computing. How parallel computing helps? More CPU can compute the job faster, because we have a number of CPUs over here in parallel computing. So it will be very helpful to complete the job faster than the single CPU system. Okay, more CPU provides access to larger memory pools. Okay, so the larger memory pools you wanted to do, it will give a more access. Advantage of the parallel computing. So it will increase the it will reduce the time, so you can save the time and then solve the bigger and more complex problems, especially in research, in industry problems, real-time applications, real-time problems. Okay, so those areas are we need a parallel computing technique. Then cluster computing. What is cluster computing? A group of interconnected computers act as a single system. Okay, so the cost effective and scalability widely used in the research and enterprise applications. So these are the common applications of cluster computing, right? So this is a cluster computing structure, model structure I have shown here. Then single processor parallel.
So can you please explain what would be the difference between cluster computing and parallel computing?
Parallel computing, a single computer, number of cores has been divided in the processor. It's nothing but parallel computing. When you're going to talk about cluster computing, there are in my home I have 5 systems. All the 5 systems are connected to the internet. Using a single server, I can allot the work to each 5 system. But each system have a single CPU. This is single CPU. This is single CPU. This is single CPU. This is single CPU. Using the software or using the main CPU, I give the instruction to all the CPUs to perform what work has been done by the parallel computing. So through internet, this work will be done. Again, it will be collected by the main server. It's nothing but a cluster computing, right? But when you're going to talk about parallel computing, in a single system itself, you have a multi-core.
Okay,
right? Each will work parallelly, and then it will work. It's nothing but a parallel computing. Both are same, but the only thing is this system should be connected through internet in a widely used. This one will take some amount of time compared to the parallel computing. Why? Because the core which is divided in the computer itself, it will take less amount of time to collect back after the work is going to be done. But this will take some amount of time because the internet strength should be high. It should be high, but it will not be higher than this way. And then it will take some amount of time because through gateway it has to come, and the cable bandwidth you have to be take care. And sometimes if the internet is disconnected, you will miss this data, and the main server will wait for that information. Again, you need to go for the computer network technology. You need to send for the retransmission technique, and you need to find out what is actually happening, right? So this is somewhat difficult and drawback compared to the parallel. The only advantage using the cluster is the cost is very less. I have a normal 5 PCs. I need not to go for server. I can alert the work to all the 5 PCs. I ask all the 5 normal PCs to work, and then I can connect it back. But somewhat it is also have some limitation. More than high level of computation memory or processing is needed. That time I can't able to use this, right?
Okay, sir.
Are you clear, ma'am?
Yes, sir. Yes, sir. Thank you.
Yes, thank you, ma'am. Thank you. Then next one is single processor. Okay, so when you're going to talk about single processor, there are different levels. The instruction level should be there to achieve the performance, not more than parallel, but anyway, we want to enhance it. Okay, so pipelining you can do, super scalar implementation you can do, and multi-core architecture you can use, and advanced extensions you can use, right? So there are different methods. It's a very old methods. Okay, these are the very old method nowadays. No one is using in terms of research as well as the what are the workstation you have in your college, right? So they are not using this kind of HPC, but anyway, I wanted to talk about what is single processor, so that's why I'm showing here. And then pipeline processor. This is the very important. This is non-pipeline structure, and this is pipeline structure. Whenever the work is going on, see the fetch, decode, execute, and then the write, all are continuously happening without delay. But here the fetch process will take, and then there is a 3 instruction gap will be there. Then again you have a second one is decode. Then again there is a 3 time period is gap, and then you have a execute. Then again you have a 3 gap. Then you have a this one. The color is blurred there. People may think that is also white. It's not white. Okay. So there is a write operation. So what will happen? There is a delay when you're going to use a non-pipelined operation. Okay, non-pipelined operation, even though you have a parallel computing, you have a very good super computing, but if your pipelining and decode, execute, write are not properly done using the pipeline method, then again the performance is going to be slow, right? So the new instruction enters every clock. Okay, so the instruction and the number of parallel stages there is no any gap at all, right? The work is keep on done without any delay over here. Then super scalar. Okay, so when you're going to talk about super scalar, what is this? You have a cache or memory. Okay, you can take memory and keep it in the cache. Then fetch unit will be ready, and it will sense whether the work has been done or not by the instructions and register field. Then this instruction will go to the decode and issue unit. Then automatically this EU will be work on it, and then you will get the response how it's going to be performed. It's nothing but a super scalar. The meaning of super scalar is compared to your parallel or cluster computing, the information will be always pipeline, and the decode issue or your instruction will be already known by the register file. How I can explain that? See, the register file will have information about the instruction set and which one have a highest priority. Based on that, this will give an input to here. So based on this input, that particular high priority computational issue will come into the picture, right? So that will be work first priority to complete that work. Okay, but it is in the sequential manner. But anyway, this is also very slow compared to the parallel computing and cluster computing. But this is another way how the HPC is working under super scalar technique. Okay. So multiple execution units can be done, and sequential instructions and multiple issues will be there in this method. Okay, then next one is multi-core processor. Already I discussed about this multi-core processor. In a single CPU, you have a n number of cores. Each core, people may say that, right? I brought a workstation. There is a 8-core processor, 32-core processor. A single CPU has been divided into 32 parts. It's nothing but a 32-core processor. A single CPU has been divided into 8 core. It's nothing but 8 core processor. So each core can capable to work each work. If it is a single core, single CPU, at a time only one work can able to do. If you have a 8 core, at a time 8 different work I can do. If I wanted to use all the 8 cores as a single work, at a time, all the 8 core put together to work in a single problem statement to execute that simulation, right? So it's nothing but a single computing component with 2 or more independent processing unit. Okay, you have a 2 or 3, more than 2 or 3 more independent processing units will be there in a multi-core processor. Each unit is called cores, as I already informed, which read and execute program instruction separately without waiting for one person has to give the instruction. Without giving anyone's instruction, it will read and execute separately. Okay, so there is a what do you say, gap. Okay, there is a there is no any super to verify what is actually happening. Each core will act as a different CPU, and each core can fetch, can read, can decode, can execute. All the works will be done without someone's permission, right? It's something but a multi-core processor. Okay, shall we go 10 minutes break? Yes, sir. Hello.
Okay, sir.
Shall we go 10 minutes break, ma'am? Then let me join again. Okay.
Okay, sir. Okay.
Yes. Shall we start, ma'am? Hello, am I audible?
Yes, sir. Audible, sir.
Shall I start, ma'am?
Okay. Okay, sir.
Yes, yes, okay. So the
Yes,
multi-core
yes,
processor,
sir.
but here independent processing units will be there between the single computing component itself. So each and every core, the CPU core will not wait for the main core has to give the instruction, right? So it's a multi-core processor, and also each CPU core have its own cache memory, and then GPU, and then it have a pipeline setup, right? So the processing speed is compared to the parallel processor, multi-core processor is high. The only thing is the each and every CPU has to be finally interact with the what is a combined series bus, right? So the bus connection should be series over here. So that the speed will be reduced. So that's the thing. In the multi-core processing, you can't able to increase the number of processors more than 3 or 4, right? So because the bus will be dumped, the interface between the your cores will be dumped, and then it will take a lot of time to collect the data or send the data, right? So that is the problem. So the cache which is present in the bus will be difficult to perform. That is the only drawback in when you're going to talk about multi-core processor. Okay. So the next one is advanced vector extension. So this is another way of process. See, what are the process we have discussed? We have discussed parallel processing, cold processing, and then multi-core processing, right? So we have discussed a lot of processor. From that, this is one of the another one method of advanced vector extension is another method of processor useful for algorithms that can take advantage of SIMD, single instruction multiple data is one of the method. Using this instruction, still now we didn't talk about what kind of instruction. Here using SIMD instruction, it has been working, is the main advantage of VAX. VAX was introduced by Intel and AMD in x86 architecture. What is x86 architecture? Have any idea about what is x86 architectures? Whenever you have some x86 architecture, what it talks about? You know microcontroller and microprocessor, right? 8085 microprocessor, 8086 microcontroller. What is the difference between 85 and 86? 85, 86 architecture. I will put a question like this so people may know about that microprocessor, microcontroller, so you can get it back, get the information from this. Yes.
Sorry, 86 microprocessor, sir. 8051 is a microcontroller.
Okay.
Yeah.
What
microcontroller? 8051 is a microcontroller. Okay. 86 is a microprocessor.
All the 86 processors are. All the 86 processors are 16-bit processors. Whenever you are seeing any processors, if it is end up with 86, is nothing but 16-bit processor. The processor which can perform all the arithmetic and logical operation 16 bits at a time. That's a beauty. But if you go talk about 84 or 85, all those things, the processors are 8-bit processors. So the time comparison between 86 and 84 is half of that. Okay, so that is the difference. Okay, so the AVX was introduced by Intel initially. Okay, initially Intel and AMD have been used with the architecture of 86. Then they will use AVX 512 application pack of 32 double precision or 64 single precision floating point operation. What is double precision and single precision? What is a double precision? After 32, there is a point 2 bits you can work on it. 64 bit, 64 single precision means 60 after 64 bit, 0.1 bit you can float. More than one bit, it is not possible to float, right? So these are the era of how AVX has came. Okay, so initially the AVX has instructed with the help of SIMD. Then the Intel and AMD are the manufacturers. They introduced the x86 architecture, right? And then after that they came AVX 512 application pack. That is application pack means it is commercial usage. Okay, so that they use the 32-bit double precision or 64 single precision floating point operation. Then 8 6-bit operation and 16 32-bit integrated. So these are the different generation of AVX processor as came. Okay, so what is the main aspects of this accelerator performance for the workload such as significancy computing, machine learning, and image signal processing. So these are the main areas where you can use this kind of advanced vector extension processes. Okay, so this will be wherever you wanted to work in image and signal processing, in those areas they will use the advanced vector extensions. May know what is signal processing? See, people know why first day, first show movie. Why I want to go for first day, first show movie? Any idea? Any idea? First day, first show movie. People are going first day, first show movie and taking photograph and then putting in the status. Why that culture has came? First day, first show movie. Why that culture has came? Have any idea about began this? Because I wanted to relate the concept to signal processing. That's why. What is the reason began this? Have any idea? See, earlier 2000, all the images, sorry, all the videos and audios are stored in the form of analog. When the data are stored in the form of analog, it's nothing but a tape. We call it a tape record. Tape record, radio tape record we can call, right? And film also will run by the some rotation person will rotate, right? There is a film. The film will run. When it is running, you can see when the light is falling on the film, it will be shown in the white screen. This is the way how the movies are there in previous before the invention of digital system. Digital signal processors came. So what is the meaning? If you go first day, first show, you can see the image and audio clearly. If you run the same information nth time, that is 100th time, 80th time, what will happen? You can see some strip lines in the image, in the video. As well as the voice, gents voice become ladies voice become gents voice. What's the meaning? Information is get lost. So what is actually happening? Whenever you have any information, the information is which is stored in the form of analog. If you read n time, the information will get lost. That is why in tape record also, if you buy a cassette, a new cassette, you want to listen songs, 6 or 7 songs will be there. If you want to listen all the 6 or 7 songs, if adjacent home they are asking to give one time I wanted to listen, we will not give. Why? Because if it is exit maximum 50th time or 70th time, what will happen? The information which is stored in the tape record will get lost because the information is stored in the form of analog. The beauty of digital signal processing is information is stored in the form of digital. So if you go nth show, nth day, signal will not get lost. Meaningless. Nowadays, if you go first day, first show, it is meaningless. If you go first day, first show, 25 years or 30 years before, that is correct meaning. Why? Because the first day, first show, you can clearly see the picture. You can see the image, what is displayed in the screen. You can listen the voice clearly. If you go second day, fourth day, what will happen? The information is get erased, and the image also you will get some strip lines and blurred one, so you can't get the proper signal, proper information. So information is properly processed with the help of signal processing, because the information is stored here is in the form of digital signal. That's why we call it image and signal processing. See the term which is present, right? Only image. How you will get video? If you have an image, right, the image which is running in terms of more than the speed of the eye movement, we can call that is video, right? So image and signal are processed properly. You will get the video with the audio and video. You will get it, right? So that is nothing but your image and signal processing. That is the reason nowadays all the signals and signal and image processing are processed with the help of digital system, right? So the digital system is a main source or tool which is used to perform all the analog information to digital. See, naturally all the informations are analog. In nature, if you go to see everywhere, I keep on talking, right? I'm talking here. The I'm talking is analog. The analog information is sent to my microphone. In the microphone, which is converted to, in the form of electrical. That electrical signal is going to your sampling and quantization, which is converted to analog to digital, which is stored in my system. then again what is happening in the internet, it's coming ones and zeros only. In your system, when it is reached your system, the ones and zeros will be converted to desampling and dequantization, which is given to the electrical signal. That signal is given to your microphone. You can listen by voice. This is what actually happening over here. So all actually the information is analog in nature, but you wanted to store, you wanted to see, now we are putting in the record, right? It is in recording. It is storing our information in the form of digital. That is what actually happening. If you store even a 200 of crores, your information will not get lost. Some song or image which is stored in your system, if you go and open nth time, you can listen, your information will not get lost because which is stored in the form of analog digital. That is the beauty of why image and signal processing is very, very important in the computer science and EC environment, why the people are always working in this area. Okay, this is very important. Why it's going actually, what is actually happening behind this, right? So this is the reason why we wanted the image and signal processing. Yes, right? For that, if I want to do a proper signal and image processing system, I need a beautiful processor. A beautiful processor is nothing but a HPC. This is one of the applications I'm talking about. This is one of the applications. Those applications I need a HPC, right? So without HPC, there is no any possibility to get the image and signal processing over here, right? So this is one of the example why we wanted the first show. We wanted to store your information, right? You wanted to listen to the movie, right? Then we will go for the next one. It's nothing but a supercomputers, okay? Designed for unmatched speed and performance. What is unmatched speed and performance? What is unmatched speed? What is unmatched speed? What's the term or what's the meaning behind this unmatched speed? Anyone in the group? It talks about the speed of your yes. Somebody's ready to say.
Speed that is you required for computation. That is the computing power is very high or maybe it is low.
No, actually, what the meaning of unmatched speed is, I have a supercomputer. The supercomputer will work some solution, some complex system is issue is working on it. The speed should be higher than that of the data which is coming to the processor. The data which is coming from to the processor, the network, it should be failed to give the data to the processor. Can you get my point? When you say unmatched speed, the speed of the processor is very high compared to the data which is coming to the processor. So the network speed is very less compared to the supercomputer speed, but that's not possible. This is an ideal case. When you say ideally a supercomputer, the supercomputer speed should be very, very high compared to the speed of the data which is pumping to the processor. Okay, so that is called unmatched speed, unimaginable speed. We can say other term, unimaginable speed. Okay, and performance. Okay, so it is designed for unmatched speed and performance. Example, Japan and USA, they have introduced a new method, new supercomputers, and they're giving that FOCO and then Summit. These are the different supercomputer names initially what they have been invented, and the applications, scientific solutions, okay, AI, because AI is very important nowadays moving, and advanced research. Those are doing advanced research areas, multi-core and multi-array applications. They are using this advanced research. Those applications we need a supercomputer. Without supercomputer, it's not at all possible, right? Here, there are the two different examples of supercomputer I'm showing. One is Carry supercomputer, and another one is Param Yona 2. It's nothing but a Indian supercomputer. This is an Indian supercomputer in NIT Tiruchirappalli. We brought Paramborul 2. Paramborul 2 supercomputer. We brought it. We have spent the 10 crore for only supercomputing. Each and every department, all the research scholars has been allotted by 1 crore. Okay, one crore they can use. I have two full-time PhD scholars. Each scholar allotted by 1 crore. Okay, they can work from their home itself. In the system, they can connect wherever they wanted to sit and they can work it. In the Paramporul, there is a totally 1,175 cores are there. Cores are there. Core processors are there. Each core allotted to each student if you give a request. Right? So you need not to buy a supercomputer in each department. Okay, all the department students they can use. Once they completed, they should hand over the code to the other student or hand over to the maintenance person who's using it. It's nothing but a paramporal. We call it as a paramporal 2, right? Similarly, paramporal Yova is the another method of supercomputing system which is kept in one room with a temperature of 15 degrees Celsius. Okay, no need to go over there. They will allot to you. It will be permanent once you are putting that username and password. You directly connect to the core and you can run on it. Wherever you are in the world, you can connect to that particular system. You can work on it, right? So that is the advantage of how the param is working. But I don't know what is this scary computer. It may be invented by some other country, and how it is working. That also I don't have any idea. This is param. Our Indian government has given this some of the reputed institutions, centrally funded institutions, to work on it, and based on the NIRF ranking, they are allotting this. But recently, 2 years back, we purchased this paramporal in our institution, right? So this is one of the example of the supercomputing technique, supercomputing facility which is located in our campus. Okay, so distributed computing, we already discussed about what is distributed computing, isn't it? Multiple systems works on a shared task, isn't it? Multiple systems works on a shared task, means the number of tasks should be more. See, you can see root request from tenant 1 to shared, root request for tenant 55 to shared A, root request for tenant 277 to shared C. What's the meaning? There is a different types of requests are coming. Whenever the root and the core and the system is free, it is root toward that particular system, right? So see, you can see here number of systems are there, and based on the query, the application instruction can be sent to the particular path, and it is connected to your settings. So the settings will check it out like a routing network. Okay, routing protocol we have been studied in the computer networks. It's a similar method. It has been used to check where you can send, whether availability is there or not, bandwidth is efficient or not, or the core which is ready to accept that, whether it is a 64-bit or the data which is coming is 64 or 32. All those things, everything is going to be checked by the settings. Okay, so the settings will be helpful to check where it has to go and what is the importance of this particular case. Okay. The next one is grid computing, distributed architecture for resource sharing. So you wanted to share your resource. What you call here resource? What you called here resource? They are saying resource sharing, right? What is the terminology here? Resource. What they are saying here? Resource. What is meant by resource here? Yes. What is here resource? Resource is nothing but not only for the hardware, it talks about software, right? So what they're doing in a distributed architecture, the software also you can share among in your group, right? Like that, the software has been made, and it will give number of keys. Let's say if I am purchasing some software to work my research, 30 keys if they are giving, up to 30 systems can connect at a time. If 31% is coming, you can't get the license to use that, right? It's somebody resource sharing. Not only for the hardware, here your software also it should be shared. Okay, so it's nothing but a resource sharing and applications in the collaborative projects. My voice is audible. Okay, this mic only. Okay, right. So yes, ma. Thank you. Thanks, ma. So the control server will be there. The control server will check how many nodes it is be connected using the grid node, and only how many keys you have. Only that many client can be able to connect. After that, it's not possible. You have to wait. Anybody is going out, then only you can connect it. It's nothing but a resource sharing in terms of software also. Cold computing in HPC. On demand access, computational resources will be there. For example, Amazon, AWS, Google, Cold Platform. I think you people know about these things, so that's why I'm going fast. And flexibility and scalability will be there when you're going to use cold computing HPC, right? So here application users, license servers are there, which will be connected synchronous with the HPC, and the HPC will be routing towards where the application is going to be, right? So all these things are connected to be the synchronized HPC. This is one of the applications of HPC where we can use. The next one is high performance networks. This is a very important when you're going to talk about high performance networks, because Even though you have a very good computing technique, very good core, you need a very high network system is needed, right? Role in interconnecting HPC nodes. What are the main roles in interconnecting HPC nodes? The HPC nodes has to be sensed, has to be directed without wasting the time and utilization of the nodes, utilization of the core, right? That's the main role of the high performance. When you say high performance network, this is the first thing. The second one is the network, the cable, the physical layer which is connected between the two nodes should be technically sound. Okay, the technology should be high. Ethernet you have to use or InfiniBand. What is InfiniBand? I've heard about this term, InfiniBand cable, InfiniBand. I'm talking about the hardware component. What is that InfiniBand? Yes, InfiniBand. People know Ethernet. The bandwidth should be infinite. Where you will get infinite bandwidth in ideal case? Optical, right? So optical fiber have a huge bandwidth, right? You can either between the nodes, say, let's say if I have a node here, I wanted to connect all the nodes. This is let's say this is main node and these are the client nodes. So this is client node 1, client node 2, client node 3, client node 4. Between the nodes, what you are connecting, it may be a star connection or a mesh connection or what are the different network technologies there, you can use it. If between the nodes, if you're going to use the connecting cable is optical fiber, then the speed will be high compared to the Ethernet, right? So that is what they're saying, high performance network. The network between the main and client, it's called high performance network. So it should be sound. It should be sound. Okay. Important to reducing communication latency, because that's the main aim of what kind of cable you're using. The main aim of what kind of cable is using is the speed of the data transfer between the main and client should be very high. And the next one is reduce the communication latency. Okay. This is a very important point. When you're going to choose your high performance networks. When you say networks, when you say high performance network, you have to be very much careful regarding this communication latency as well as the interconnecting HPC nodes. Okay, so this is a very important high performance networks usage. The next one is, this is very important. People have to know about clearly programming models. How can you program? Okay, how can you program the models? Okay, MPI, message passing interface, is one of the method. OpenMP, shared memory program, is another method. CUDP, CUDA, we call it programming for GPU. Wait, I will explain what is this. When you're going to talk about programming the models, you have to go all these steps. If you have failed to do any one of these steps, okay, if you failed to do any one of these steps, automatically your system will be failed in some threads. Okay, so that is very important. First, what you want to do, you have to gather the data. You need to know about a complete set of data performance. Okay, you need to gather the data, how it's going to be. Then you have to prepare the data. Then data warning will be there. Okay, then analyze the data. Then train the model. Okay, based on the data. That's what very important. Based on the data analysis, the output of the data analysis will help you to how to train your model, like AI and ML. Right, so your data set is very important. How you will get the data sets? Once you analyze the data, right? So the analyzation step is very important. You need to analyze properly. Once you analyze properly, the analyzation of this one will lead to give a proper trained model. Then the trained model you have to test properly whether it is working. Then you have to deploy to the client. This is the programming model which have been generically used or commercially used or commonly used anywhere when you want to test your system should be properly working or not. Okay, so you have to be, remember, the first one should be gathering the data, the second one should be data preparation, third one is data warning, and then analysis data. There's a very important step. Based on the analysis data only, you can train your model. The trained model will help you to create a test model. The test model have to test in different environment, in the laboratory, in the real time, in the stored data, in already processed data, already known some output, and that data also you have to apply and check it out how it performs. It's nothing but a test, not only testing in a single area, single environment to find out how it performs. You have to check all the areas. Everywhere it is fine, everywhere it works, then only you have to deploy this to the deployment section. So this is the way how you can model your program, right? So when you want to program, irrespective of, not only I'm talking about HPC, any programming model, these are the basic steps you should follow before you're going to be implement on it. Okay, people know about that. You have a television, right? You have a television in your home. Not now, 15 years or 10 years back, if you go and check, cable connection will be there. It's called a cable connection. Nowadays, everyone will have a dish antenna, isn't it? Everyone will have a dish on the top of the roof, and then from the roof of the roof antenna, which is receiving the signal, which is coming to the set-top box, and the set-top box we can connect it to the television, that is TV. So you are receiving all the signals. That's what actually happening over here. Right? Why I'm saying this, how it's going to be modeled. That's what I'm explaining to your programming model to your television. Okay. So what is actually happening? It is connected. If you go and see in previous case, that is 15 years before the invention of your dish antenna, all the TVs are interconnected with the cable TV, right? Cable connection, Sun TV cable connection. Like there's somebody will, some X or Y will give a service provider, and then the service provider will give the connection. And then if any fault is there, you have to call him. He's a local guy. He will come and repair, and then he will do some repair, and then he will give the connection. Every month they will collect the money. Like nothing is going on, right? Have you tested anybody? If you cut the cable, connect another cable, and connect it to the another channel, another TV in your home itself, you can see, you can turn on both the television. You can see both the television at a time in a different channel. Can you get my point? Let's say one cable is running to my home. In between, I'm cutting and I'm splitting into two parts. This I'm connecting to one television. This I'm connecting to the first floor. Let's say this is ground floor TV and this is first floor TV in a single home. If I switch on this TV as well as this TV at a time, or sometimes simultaneously, or half of that also, I can only turn these channels, different channels. Again, here also I can see different channels. Have you tested this? Anybody, please? In a single home, two different TV, two different channels you can see at a time. If I'm seeing Sun TV, another channel, another television, I can see some other channel. So,
yes, sir.
Yeah. What is the meaning? There is no any security at all, because it's not programmably modeled over here. So the programming model is missing. That is the reason you can see. But in your home, don't cut. But anyway, I'm saying in your home, after set-top box or before set-top box, if you're going to connect one more cable to another television, you can't able to see a different channel. At a time, you can see only one channel. Both the television will show only one channel. Even though you are changing to the other TV, you can't see a different channel, because there is the programming properly programmed and secured. The signal is properly secured. Only one time it can decode at a time. It can't able to decode more than one time to a different two channels, because the dish which is connected in your top of the roof and your dish or set-top box which is present in your home are planned, properly tuned only to allow a single channel at a time. It cannot allow to one more channel at next time. That too, you should cut after the set-top box. If you cut before the set-top box, you can't get the signal, because the set-top box will act as a decoder. It will decode the data which is running from antenna to your set-top box, and it will properly give to the analog signal to your television. So the analog and the television know only to read the analog signal. It can't able to read the digital. So output of the set-top box will be analog. So analog signal is received by your television. The signal is received. So what I'm trying to explain here is in the modern dish-based television system is properly modeled by the program. So the program is properly modeled. They gather the data. The data preparation will be the data warning will be the data analysis will be the then data is properly trained. Only one channel has to be sent, and that is tested, that is deployed in your television. You can't see. But in previous case, if you go check in television, that is by connected by the cable connectors, you can see n channels. The only thing is the signal strength will reduce, because we need a booster. Every certain television are connected, they will put boosters. Now also you can see in roadside like what do you say, 1 feet or 1.5 feet black color. What is that? Cylindrical shape pipe will be connected inside and it will go out. It's called repeaters, the energy boosters. Power will be energies. Okay, so after 100 TV or 200 television, they will put one repeater or booster. Then again they will connect another 200 TV. Like that it will go. If you enhance the number of TV, what will happen? Number of channels, what will happen? The signal strength will not be good. The signal will get blurred. Okay, so that is the difference between that one. But anyway, here there is a security based on your signal is properly modeled by using the programming language. That is the advantage I want to say. So after this, I'm stopping. Remaining we'll see in the next class. Anyway, tomorrow I have one more session, evening 6 to 7:30. So that time I will continue this. Then I will go to the programming for HPC. Okay. So what are the rest of the part will be that I will continue in the next class. And then I'll go to the programming language. Anyway, I don't want to go rush up. That's why I'm going very slow to explain each and every concept in detail. People have any doubt, you can ask now.
Sir, in what way quantum computers different from supercomputers, sir?
Quantum computers are actually the cores are connected. Let's say I have 8-core processor. Okay.
Yes, sir.
Between the cores, they use the quantum technology. It's nothing but an optical technology to interconnect the cores. But when you're going to talk about supercomputer, they will not use a cable, optical cable between the cores. Can you get my point? See, let's say I have 8 cores in a processor. Each core should be connected by a cable. It's a bus. We call it as a bus. The bus which is connected between the cores are optical cable. The cable which is running between the cores are optical line, optical fiber. But when you go to talk about supercomputer, it's not optical fiber. There is an electrical signal. So compared to the supercomputer, the quantum computer speed will be high, right? Because there is a chance to reduce the electromagnetic interference if you're going to use the quantum processor. That is the main difference. So I can say that compared to the supercomputer, quantum computer have a huge speed.
Oh,
it's the advance of your supercomputer. It is also one type of supercomputer, but compared to the our traditional supercomputer, the quantum supercomputer is very high. And the cost also very, very high.
And also we can say it's based on electronics. So this one is based on spintronics.
No. Both are based on electronics, ma'am. The point core to core, if you are using optical, what is actually at the end, again, you need an optical to electrical converter.
Yes, sir.
Both are electronics only. Both are electronic. There is no any electrical or electronics or optical like that. Okay. What I can say, if I'm floating a water in the floor, it want to reach to 3 meters, it will take 1.5 minutes. If I'm sending to a pipe, what will happen? The water flow will be very high, isn't it? Hello?
Yes, sir. Yes, sir.
Same way, if you send a signal through electrical signal, the speed of the electrical signal is lesser than the speed of the optical signal which is flowing into between the core. So that's the reason the quantum computing is somewhat higher, faster than your supercomputing.
Okay, sir. Thank you, sir.
That's why if you go and see some of the service provider, ATAL, ACT, all the service providers, they will say, Geo also they will say, Geo fiber network, optical fiber Geo. If you want to connect your Wi-Fi in your home, they will put a term Geo optical network. ATAL optical network, meaning is the cable which is running to your home is optical network. So fast is very high. Compared to your electrical Ethernet, if you're going to transmit, compared to that one, this is very high, and you need not to worry about the speed. The speed is huge. The buffering is gone because of this optical cable which is running up to your home. In the home, you have a set-top box, right? In the Wi-Fi box is there. It is connected optical. The output is going to be electrical. Then it creates the antenna with the help of antenna. Electromagnetic signal will be in the range of 10 meters. So in the 10-meter range, if you are sitting in your home, you can receive all the signals. So wherever you wanted a high speed, right? You don't want. You are not tolerating the. You are not tolerating the time period. You wanted to immediately communicate. You immediately want to do the signal transmission. You have to go for the optical, because optical is very high compared to the electrical. That is the reason in the quantum computing they are using optical cable between the cores which is plus the processor. Okay. Hello, ma'am. I'm clear, ma'am. Am I audible?
Sir, yes, sir. I got the point, sir. Thank you, sir.
Thank you.
Sir, it is the only difference of the transmission medium. Is there any other difference, sir, in quantum computing?
No. As per my knowledge, up to now, only they are concentrating in the processor, because processor is a very, very important one compared to other part. If you want to act as a HPC, when you want to talk about high performance computing, process speed you need to enhance. What are the different methods and technology we can use to enhance the speed? That is what they are trying.
Okay, sir.
Shall I wind up? Okay, thank you. The remaining we'll see in the next class. Okay.
Okay, sir. Thank you so much.
Tomorrow I'll continue the remaining part.
Okay, sir. Thank you, sir. Nice presentation.
Thank you. Thanks, man. Thank you.
Thank you, sir. Thanks for your time. And over to you, Mariam Nancy, ma'am. Hello, ma'am.
Yes, I'm
yes. Sir, Dr. Ranjit, sir. Sir, can you hear me, sir?
Yes, sir.
Yes, sir.
So we'll start, sir?
Yes, ma'am.
Good evening to one and all present here. It gives me immense pleasure to introduce Dr. Ranjit R. Dr. Ranjit is currently serving as an associate professor in the Department of Computer Science and Engineering at St. Joseph's College of Engineering, Chennai. With a robust academic background, he holds a PhD in Information and Communication Engineering from Anna University. Dr. Ranjit brings over 10 years of academic experience with a diverse portfolio roles, including teaching, research, and administrative responsibilities. A passionate educator, he has imparted knowledge in a wide array of subjects such as Python programming, artificial intelligence, machine learning, data structures, and the Internet of Things. His leadership skills are evident from his roles as a coordinator for IEEE ACC AI conferences in 2023 and 2024, and Nodal Center Coordinator for Smart India Hackathon in 2023, a prestigious national level initiative by AICTE. Today, Dr. Ranjit will share his expertise and insights with us, drawing from his extensive experience to inspire and empower participants with advanced knowledge and practical applications in these transformative fields. Please join me in extending a warm welcome to Dr. R. Ranjit. Over to you, sir. The session is yours. Thank you.
Thank you, ma'am. Good evening. I will share my screen. Ma'am, is the screen visible, ma'am?
Sir,
Yes,
I can see your web page. I hope you haven't shared the PPT yet.
Now, sir?
Yes, sir.
Yes, sir. Yes, sir.
It is visible.
Okay, sir. I'll proceed. So today we are going to see high performance computing architecture. So the contents goes like this. It goes to introduction to high performance computing, parallel architecture, multi-core architecture, GPUs, clusters, grid computing, and cloud computing. So I hope you have already seen about what is high performance architecture, but just a small introduction. So high performance architecture is nothing but the ability to process data and perform complex calculations at very high speeds. But high performance computing is different from supercomputers. Supercomputers are used for specific purpose. High performance computers are used for general purpose. So one of the So one of the supercomputer is IBM Blue Gen P, Interpret, a national laboratory runs of processor cores of 1,64,000 using normal data center and air conditioning grouped in 40 racks cabinets and high speed of 3D Taurus networks. So when we need a high performance computing, so we have 3 case studies for here to discuss. So case 1, here what you're doing, you're going to complete a time computing operation in very less time. Suppose you're an automotive engineer, you need to design a car that computes less gasoline. So rather completing the design in 6 months using HPC in normal computer, it takes around 2 years. And simulation in a high performance computer will be very good. So in such time consume, to reduce the time, you will use HPC under such conditions. Second condition, you will have when you have to stringent the deadline, you will use HPC. So for a weather forecasting, suppose nowadays weather forecasting or accurate in number, this is because of high performance computing. So for weather prediction agency to input weather sensors from various sensors and predicts the tomorrow's weather today, you can use HPC. Next, in case 3, what you are going to do, you are going to perform high number of operations per second, millisecond. If you need to execute certain operations, then in such cases you will use HPC. So example, there is an Amazon engineer, so his web server gets 1000 hits per second. So to handle database and 1000 transactions, we can use HPCs. So when you will use HPC, when you need to reduce the time, when you need to meet a deadline, and when you need to execute instructions at very minimum seconds, then such conditions you will use high performance computing. So basically what does high performance computing include is a processor. Processor is usually GPU or CPU, a hardware, a very good hardware. So hardware compute of architecture and network connections, and software. Software uses programming models like MPI. MPI is message passing interface, shared memory, PSGS. An application is open source and commercials. So how does HPC work? HPC usually works on 3 main components: compute, network, and storage. Compute mainly consists of clusters. Clusters are nothing but group of machines which are interconnected in a way that they work as a single system. Cluster is nothing but a group of machines interconnected in a way such that they work in a single system. So a cluster will consist of a node, a headmaster, and a compute nodes. Node is nothing but a normal cluster. Headmaster is nothing but, in sensors you have seen, you have a base node, head node. So like that, clusters will have a headmaster node, and computer node will use to connect it to private networks and run the jobs assigned to them based on the head nodes. So together with these components operate seamlessly to compute a diverse set of tasks. So parallel architectures. So when seeing parallel architecture, traditionally software is written in serial computation. So in serial computation, what will happen? A problem is broken into a discrete series of instructions. Those instructions are executed one after the other, and they are executed in a single processor, and only one instruction is executed at a time. This was traditional CPU based serial communication was used. Parallel communication you can see in pipeline architecture. Pipeline, you will have four instructions basically: fetch, decode, execute, right? So when one instruction is fetched, and when it moves to decode, second instruction would be fetched. So it goes on like a pipeline: fetch, decode, execute, right? So if you have 4 instructions, 3 instructions will be executed simultaneously. So that is called as pipeline architecture. Parallel architecture is simultaneous used to solve a computational problem. So in parallel computing, a problem is broken down into discrete parts that can be solved concurrently. Concurrently means parallelly. So each part is further broken down into a series of instructions. The instruction executes simultaneously on different processor. In serial, they will execute on same processor. In parallel computing, they will execute on different processor. Overall control coordination mechanism is employed in parallel computing. So parallel architecture, as said earlier. So if you have a do function called do payroll, there will be processor. So serial computing, first instruction will be executed, that is T1. Then second instruction will be executed T2. So on Tn instruction will be executed. In parallel, what will happen for employee 1, you will have a set of instruction executed in a processor. For employee 2, you have a set of instructions to be executed. For employee 3, you will have a set of instructions executed parallelly. So this goes on for n employees. So if serial computing will take, suppose if you have n instruction, it will take n times. Parallel computers will obviously take time lesser than n, because instructions are executed parallelly, usually n by 2. So how is parallel architecture? So parallel architectures goes on virtually as standalone computers from hardware. So you have multiple functional units, namely L1 catch, L2 catch, branch, prefetch, decode, floating point, GPUs and integers, etc. You have multiple execution cores and multiple hardware thread. You have more than one threads. Threads are nothing but lightweight process. So networks are connected to each processor for seamlessly transisting this, making the processor execute simultaneously. So now we are going to see why are you going to use parallel architecture. First is to save time. Save time is execution time will be saved, and money in the sense executing n times will cost more than executing by n by 2 times. Next, larger problems is broken into smaller sub-problems. That's why we use parallel architecture. Parallel architecture provide concurrency, and they take advantage of non-local resources. And hardware for parallel system is little bit costly, but when you see the execution time, those cost is very minimal. So there are two types of parallelism, namely data parallelism and task parallelism. So data parallelism focus on distributing data across different parallel computing nodes. Task parallelism focus on different tasks. So it follow also called as loop level. Data parallelism is also called as loop level parallelism. Task parallelism is also called as functional parallelism or control parallelism. So for example, if a CPU A could add all elements from top of the matrix, while CPU B could add all elements from the bottom of the matrix, so that our task becomes easier. In task parallelism, if you are running two code processors, CPU A's and B in parallel environment, we will complete A task in one parallel system and B task in another parallel system, so that it reduces the time of runtime of the execution of the task. So parallel architecture, there are four types of parallel architecture based on Flint's taxonomy, namely SASD, SAMD, MISD, MIMD. As the name goes, SASD means single instruction stream, single data stream. SAMD means single instruction stream, multiple data stream. MISD goes like this: multiple instruction stream, single data stream, and MIMD goes like this: multiple instruction stream and multiple data stream. So we will see these architecture for a clear understanding. So SASD is single instruction stream, single data stream. So it is the instruction pool is connected serially. Only one instruction and one data stream is acted. So only one clock cycle is being executed. Example: old generation mainframe computers, mini computers, and single processor PC use SASD. SASD is single instruction stream, single data stream. So you have only one instruction set and one data set. In SAMD is single instruction stream, multiple data streams. So you have one instruction pool and multiple data pool. So in this SAMD concept, what will happen? All processing unit execute the same instruction at any given point in a given clock cycle. For one clock positive and negative clock signal. So each processing operates on a different data element. Modern computers such as GPUs use SIMD, single instruction stream, multiple data stream. Modern computers use SIMD concept architecture. So now we are moving to the third architecture. Third architecture is nothing but MISD. MISD is multiple instruction stream, single data stream. So in MISD, you have these different operations operated on a single data stream. So you will have one data stream and multiple instruction stream. So example, cryptography algorithm, RSA algorithm, SH algorithm, you should convert 8-bit to 256 bits. So in such application, you will use MISD archetype of architecture, multiple instruction stream, single data stream. Lastly, we are seeing about MIMD. MIMD refers to multiple instruction stream, multiple instruction stream, multiple data stream. So in MIMD concept, you can execute different instructions on different data element. So most of the supercomputer, parallel computers and multi-core PCs use this concept, multiple instruction. So all instruction and data are executed multiply, that is parallelly. So parallel computers are lastly what we saw is based on Flint's taxonomy. Now parallel computer architecture is distributed based on shared memory architecture. So in shared memory architecture, you have two types of memory access: uniform memory access, non-uniform memory access. So in uniform memory access represent symmetric multiprocessor machines. Non-uniform multiprocessor option use physically in linking to SMTs. SMTs means symmetric multiprocessor machines. So in UMA, identical processor, equal access and access memory time are very less, where access to another SMTs. So sometimes CCUMA, catch coherent uniform memory access, is if one processor update a location in shared memory, other processor knows. Non-uniform memory access, it's opposite of it. If one processor updates, other processor need not know the updates. So memory access will be obviously slower, but catch coherency is maintained in CCNUMA. CCNUMA means catch coherent non-uniform memory access. So these two types of memory access comes under shared memory architecture of parallel computer memory architectures. So parallel computer memory architecture is further classified based on third type. Third type is nothing but distributed memory architecture. So in distributed memory architecture, what happens? Each processor has its own memory. So programmer is responsible for communication between the two processors. So each processor has local memory which operates independently, and any changes made in the local memory will not affect the memory of other processor. Hence, the concept of catch coherency will not apply here. I repeat, in distributed memory architecture, each processor has its own local memory. So if you have own local memory, it operates independently. If it operates independently, changes made to one local memory will not have effect on other processor, and hence the concept of which we have seen in catch shared memory concept, catch coherency, does not apply in distributed memory architecture. So when a processor needs to access a data, so this problem arises when a processor needs to access data in another processor. So programmer need to explicitly define how the data to be communicated. So synchronization, the task is responsible of the programmer. This is one disadvantage. Synchronization problem is one disadvantage of distributed memory architecture. So next we are going to see multi-core. Multi-core is nothing but processor, single computing component with two or more independent processing unit called cores. which is used to, these cores are responsible to read and execute the program instruction. In normal single core CPU, you have ALU. ALU is nothing but arithmetic logical unit, which is used for performing mathematical operation. You will have registers, you will have bus interface. This will be a normal CPU chip which you have studied earlier in microprocessor 8086, 8088. Now when coming to multi-core architecture, that one single core, you will have many single cores such as core 1, core 2, core 3, core 4, n number of cores. So all the n number of cores will have individual ALU and registers. All will be connected to a all will be connected to a bus interface, and it will be connected to input output ports. So this is the architecture of multi-core architecture. In short, in single core CPU, you will have only one register file and one ALU, one bus interface and one system bus. In multi-core architecture, you will have many cores. So each core will have an individual register file, ALU, and a common bus interface and a system bus to communicate between the core to that of input-output devices. So multi-core architecture is single processor socket. It is also called as chip multiprocessor. The cores run in cores. Each instruction is executed parallelly. So how will the core interact with OSs? OS perceives each core as a separate processor. So each core is considered as a separate processor, and each thread is considered as a separate processor. Major OS support multi-core architecture today. So why we are moving to multi-core, this type of architecture is, so in single core architecture, you could execute only one instruction at a time. Multi-core architecture, you can execute more than one instruction at a time. So heat problem, speed of light problem, difficulty design verification, large designs is not necessary. So it is not expensive, and air conditioning is not much needed. So many new, almost all application after Java, it is thread based. Thread is nothing but lightweight process. So if for all thread based application, multi-core application will be, multi-core processor will be very easy and it executes faster. And moreover, thread concept introduced is used to support parallelism. So in multi-core processors are MIMD, stream, multiple data stream, which we have seen already. So different cores execute different threads and operating on different parts of data. So multi-core is also called as shared memory multi-core processor. So what are the applications and benefit of multi-core? So where all, which all application we could see multi-core processor. So database servers, web servers is nothing but Amazon web server. Amazon web server is nothing but Amazon website. So you click on multiple items, so it will be stored in a cart. So multiple processor means you should store in a cart. So you should fetch the amount, it should fetch the delivery, the count. So all these execution must be executed parallelly and swiftly. So for such web servers application, we use multi-core architecture. Compiler where we need to execute more instructions at a second. So for weather forecasting, you will have n number of sensors installed all over the city. So you need to gather all the data from sensor from each point of time and execute a different set of instruction. So such type of applications use multi-core architecture. Multimedia application in the sense where graphics are much involved. So in movies or in normal any video shooting, if where graphics, example, even in marriage shooting nowadays, they are moving all the both bridegroom and to different locations all over the world. So in such graphics, you will use you need to use multi-core architecture, scientific applications, CAD CAM. So computer aided design, you will use multi-core architecture. So editing a photo while recording a TV show through a digital video recorder, you will use this. Downloading a software while running antivirus program, which means for nothing, running two program at a time. One is downloading a program and similarly antivirus programming is running parallelly. So more than one processor is getting executed. So for all these type of application, you will use multi-core architecture. So in multi-core architecture, you have a problem called catch coherence problem. So catch coherence problem is nothing but, so you have a multiple shared resource. So multiple shared resource means you have multiple cache. When client in a system maintain cache for common memory resource, problem may arise with incoherent data, which particularly the case in CPU multi-core architecture. So how you will overcome is you will overcome using two methods, snooping method and directory based method. In snooping method, protocols tends to be faster if you have enough bandwidth and all transaction or request response seen by all processor. Snooping, the only one disadvantage of snooping isn't scalable. So every request must broadcast to all nodes. Broadcast means intimate all other nodes in the system. That is the only disadvantage of snooping system. In directory based system tend to have longer latencies, but one disadvantage of directory based system is it uses less bandwidth. Because why it uses less bandwidth means it is point to point based communication. It uses point to point based communication, so less bandwidth is used. So when less bandwidth is used, you tend to have longer latency. For this system, many large system use 64-bit processor rather than 32-bit processing systems. So in multi-core coherent protocol, there will be for this example, you have four cores: core 1, core 2, core 3, and core 4. And each core have more than one level cache. Namely, you can name it as L1, L2, L3, and L4. So level 1 cache, level 2 cache, level 3 cache, and level 4 cache, namely. So each cache is connected to a main memory. So this core and cache together formed multi-core chip. So what is write invalidate? Write invalidate is nothing but when write operation is observed in cache, a copy of cache controller invalidates its own copy of the snooped memory location, which forces a read from main memory for new values on the next access. Which means when a write operation is performed by one processor, what will happen? Cache has a copy of that write instruction. Write instruction as a copy of one cache controller. So when the copy of one controller in one snooped memory location, all other remaining caches cannot access this. So write update. Second problem is write update. So what is write update? In write update operation, location of a cache as a copy of the cache controller, which updates its own copy in snooped memory location with different location in the new data. So this is how both the conditions will be fail in write invalidate and write update of the core cache, which happens in multi-core chip of the main memory. So next we are moving to next type of architecture, which is nothing but GPUs. GPUs is normal nowadays we are using. What we are using nowadays is GPU. GPU is nothing but graphical processing unit. So graphical processing unit is obviously used for 2D, 3D. 2D is two-dimensional, 3D is three-dimensional graphics, visual computing, and display. So using GPU, you can have high parallel, high multi-thread, multi-processor, which is used for visual computing. GPU is used for visual computing. So GPU provide real-time visualization interaction with computed objects via graphics, images, and video. So GPU serves as both programmable graphic processor and scalable parallel computing processor. So heterogeneous system will have both GPU and CPU installed in the system. Nowadays, all laptops have both GPU and CPU installed. So GPUs are so evolution of GPU. If you see evolution of GPU, graphical processing unit. So in 1980, you used VGA controller. In 1990s, you had more function to VGA controller. So after 1997, what you did is you added 3D acceleration function. So 3D acceleration function is used for hardware for triangle separate and rasterization, text mapping, shading. VGA is nothing but video graphic array. So it is a graphical display standard introduced by IBM. So its color depth is between 256 and it operates in 70 gigahertz. 70 gigahertz. So in 2000, what happened? A single chip graphic processor, so which is termed as GPU, a single bit graphical processor, which is termed as GPU, was introduced in 2000. In 2005, parallel programmable interface processors were introduced. In 2007, CUDA, Compute Unified Device Architecture, was introduced. So CUDA is nothing but a parallel computing platform developed by NVIDIA, which allows developers to harness the power of NVIDIA's GPUs to perform it is used to perform general purpose computing tasks beyond graphics rendering. Beyond graphics rendering, not only performing graphics rendering, it is used to perform general purpose computing tasks. In 2010, various GPUs was introduced by AMD's and G4 10 series. This was the evolution of GPU. GPU is nothing but graphical processing unit. So why we are moving to GPUs? So why nowadays data is getting increased. So to provide separate dedicated resources, including graphical processor and memory, we are using GPU to relieve some of the burden of the main system resources, namely CPU, main memory, and system bus. So which will obviously get saturated when graphical operations and IO exist. So if you keep on processing CPU, main memory, and system bus for all the data and graphical data, it gets stuck. So separate GPU, which is used for graphical programming interface, if it is used, it will be an alternative and not a burden for other devices like CPU, main memory, and system bus. So now we are going to see the difference between CPU and GPU. So GPU is used to perform parallel operation, whereas CPU is used to execute the program serially means one after the other. So GPU have many parallel execution units, whereas CPU has only fewer execution units. GPUs are obviously faster, advanced memory interfaces. They do not shift around a lot of memory data when compared to that of CPUs. And moreover, GPU have much deeper pipelines, normally several thousand stages, whereas CPU has only 10 to 20 pipelines. GPU has more than 1,000 pipelines, 1,000 pipelines used for parallel computing, whereas CPU has only 10 to 20 pipeline. So now we are going to see the components of GPUs, because GPU is separate, CPU is separate. CPU contains ALU, register, and system bus. GPU is used for graphical interface. Okay, so it will have a graphics processor, graphic coprocessor, graphics accelerator, You have next to call frame buffer. You have a memory. You have a BIOS, graphic BIOS. Graphic BIOS is nothing but basic input output. So you have a D to A converter, digital. D to A converter is nothing but digital to analog converter. Next you have a display connector. Next obviously you have a bus. So next we are moving to a concept called clusters. Clusters already we have seen. I will repeat again. Cluster is a group of loosely or tightly coupled computers that work together in many respects. It can be viewed it as a single computer. One cluster can be viewed as a single computer, but cluster is nothing but a group of processor linked to a single CPU. So it is connected through a LAN. LAN is local area network. Then clusters are deployed to improve speed and reliability over a single computer. So why they are deployed? They are deployed to improve speed and reliability over a single computer, while typically it is much more cost effective than single computers in terms of speed and reliability. Middleware is required to manage these clusters. So cluster computing, each node within a cluster is an independent system. So in cluster, each node is an independent cluster with an independent system with its own operating system. And some cases it is a file cluster. So there are two types of cluster, namely storage cluster. Types of cluster, namely there different types of clusters are storage cluster, high availability cluster, load balancing cluster, and high performance cluster. So storage cluster, as the name implies, it is used to provide a consistent file system image, allowing simultaneous read and write. Storage cluster will allow simultaneous read and write. High availability cluster provide continuous availability of services by eliminating single points of failure. So high availability cluster will eliminate single point of failure. Load balancing cluster sends network service requests to multiple cluster nodes, which is requested among various cluster nodes. So load balancing is used to see that load is balanced among all the clusters. High performance cluster used to perform concurrent calculations. So it allows application to work parallelly and so that it enhances the performance of the network. It is also called as high performance clusters, is also called as computational clusters or grid computing. So what are the benefits of cluster? So if you see the benefit of cluster, cluster is used for reduced cost, processing power is more, scalability is also more. Scalability in the sense, mainframe computers have fixed processing capability, whereas clusters can easily expand the requirement by changing additional nodes or adding additional nodes to the network. You can increase the performance of the cluster. So what are the benefits of cluster? Improved network technology. Improved network technology means it uses VLAN. VLAN is virtual local area network. Clusters uses VLAN. So each computer is treated as a separate node. So if one node fails also, we can recover it from other nodes. Next main important advantage of cluster is nothing but the availability. When one when one system fails, single system fails, which means we cannot extract the data itself, because when that system is failed, you have all the data stored only to that cluster. Whereas if you have cluster mechanism, each data, if one system fails, you can get a copy of it stored in another node, which can be recovered when required. So what are the need for cluster? So when we are need for cluster, we are going to need cluster because more computing power. Why more computing power is needed? because now data is rapidly increasing. Where it is, data is rapidly increasing from sensors, because nowadays IoT, Internet of Things, is main thing. Internet of Things for processing, whether you need different types of sensor installed. From those sensors you will get many data, so that data need to be computed with very high speed. Next, reliability. Next, performance and availability of single computer is very less, so that next, cost effective of single computer, we have cluster computer. So all this we have seen. We'll see types of clusters. So high availability cluster, load balancing cluster, computing cluster. So high availability cluster provide uninterrupted availability. Load balancing clusters distribute the incoming node to various clusters. Compute clusters is used for computation intensive purpose rather than handling input output oriented service. So in high availability purpose, performance drop is mainly occurring due to missing node. In load balancing cluster, each and every node is cluster is handle request for the same content or application. In compute clusters, you uses vary level of coupling. Example, job with frequent communication among the node may require dedicated network and likely homogeneous node. Jobs with infrequent communication between the node may relax some of this cluster. Example, rock package on Linux. For load balancing cluster, we have a system called NGINX, which is a HTTP load balancer. Remember, load balancing cluster is used to distribute the load eventually to all the clusters. Next, high availability cluster, you have an example called Oracle clusterware. Next, you have one more cluster called Behold cluster. So Behold cluster is used for parallel processing across multiple computers to create cheap and powerful supercomputers. Supercomputers are used for specific purpose, whereas high performance computing is used for general purpose. Specific purpose means weather forecasting. Weather forecasting supercomputer is costly, which is used to manipulate data of weathers, which cannot be used for general purpose. It is used only for weather forecasting. Next, nuclear reactions. Nuclear reaction supercomputer will be used in nuclear power plant. So such supercomputers is very highly deployed, very high cost to deploy. It will be used only for specific purpose like weather, nuclear power plant, like that. Whereas high performance computer will be general purpose, which can be deployed anywhere. A cluster has two types of computer, namely master or service node or friend node. So that master is also called as service node or friend node. So which is used to interact with users and manage with the clusters, whereas nodes is nothing but a group of computer, which is also called as computing node. Example keyboard, mouse, floppy video, etc. Group of computers with computing nodes. So one computer, we have many nodes connected to it. So when a large problem or set of data is given to a before cluster, the master computer, what it done, it runs the program that breaks the problem into small discrete pieces. So if it then send a piece of each node to compute, as the node finish their task, the master computer continuously sends more pieces to them until the entire problem is computed. It is nothing but model separation. So what does master computer is this? What does master computer will do means, it will split a larger problem into different submodules. So for each cluster, it will give a particular module. So once the particular module gets completed, the next piece of remaining module is given, so that a master node keeps on assigning sub problems to the clusters, such that the whole program is getting executed parallelly. So how the cluster is, now we are going to see how cluster technology is going to implement. So we are using two concepts, namely parallel virtual machine, and you have MPI. MPI is nothing but message passing interface. So parallel virtual machine, sorry. So it must be directly installed on every cluster nodes and provide a set of software libraries that paints a parallel virtual machine. So parallel virtual machine means each machine will execute differently in different machine. So it is used to provide a runtime environment, namely message passing, task and resource management, and fault notification. So for this runtime environment, you will use parallel virtual machine. Next, when you will use MPI, MPI is nothing but message passing interface. So you use this feature in commercial systems for the time. MPI is used only for specific implementation. So MPI basically use TCP, IP, and socket connection. TCP is transmission control protocol. So it is widely used in communication model that allows parallel programming, which is written in languages such as C and Python, etc. So MPI is used normally written in language such as C and Python. So long we have seen how the cluster works and what are the different types of clusters, what are the type of clusters. Now we are going to see the benefit of cluster. So benefit of cluster will goes like this, based on availability. So availability, performance is how it is getting executed. Low cost for deploying individual standalone system. You could deploy a one system with multiple clusters. So that will be very cost effective as well as cheap and best. Elasticity and runs jobs clusters used to run jobs anytime anywhere because it is connected to a LAN. LAN means local area network. Local area network, it is connected to network. So you can run it anytime, anywhere, at any moment. So that are the benefits of clusters. So next, we are moving to a concept called grid computing. So grid computing is used to combine multiple administrative domain to reach a common goal. So distinguishes, so there is difference between grid computing and clusters are these systems are similar to that of supercomputer and HPC. So it is closely tends to be more loosely coupled, heterogeneous, and geographically dispersed. So special kind of grid computing in which different computers, same kind of network share only one resources. Same kind of computers used to share one resources. Such things you will use grid computing. So grid computing those. So if you see the diagram, you have a supercomputer, satellite, cluster, virtual organization, scientific relationship officer. So what is a grid? Sharing, selecting, aggregating resources with a policy of universally agreed distributive supercomputing for better future. So this is the concept of grid computing. So you have grids. Grids is similar to that of, how will you link this is? Grids is similar to that of a tower, mobile phone tower, and the systems is similar to that of a mobile phone, where you will have one grid connected to many mobile phone cell towers. So types of grid computing. So types of grid computing. So first type is data grid. So what is data grid is? Data grid is allow you to distribute your data across the grid. Data grid is used to allow and distribute data across the grid. So the main goal of this data grid is used to provide much data as possible from memory on every grid node and ensure data coherency. So what are the characteristics of this data grid is? First characteristics is data replication. So what do you mean by data replication? Data replication is all data is fully replicated to all nodes in the grid. All replication means copy. A copy of data is to be stored in all the grids. Data invalidation. Data invalidation means when the data is changed in one node, when data is changed in one node, the same copy of data should be changed in all the nodes present in different grids. That concept is called data invalidation. Data replication invalidation differs. Replication means a copy of one data is stored in all grid, whereas data invalidation means whenever data changes in one node, that copy of the changed data should be replicated in each and every node. Next, distributed transaction. Distributed transaction is used to ensure data coherency. Data backup. Data backup, when it is used, when you use failover, when some grid fail, you need to get, transform and assign and fetch from all other grids. Data affinity and partitioning. Data affinity and partitioning is used for split partitioning old data into multiple subsets and assigned to every subset of the grid node. So these are the characteristics of grid computing, which are data replication, data invalidation, distributed transaction, data backup, data affinity, and data partitioning. So if you now we are going to moving to second step, which is nothing but computing grid. Computing grid is used to take computations, optionally split it into multiple parts and use which is all these are executed on different grid nodes in parallel, which leads to faster rate of execution. Example, map reduce concept you also already see, which is used to improve overall scalability and fault tolerance of offloading your computation. So now what are the characteristics of compute grid is automatic deployment, topology resolution, collision resolution, load balancing, checkpoints, grid events, and node metrics. These are the characteristics of computing grid. So grid events mean mechanism which is used for querying all the data in the grid. Checkpoints means it is nothing but save point. Checkpoints and save point are the same. So in system, what you do if you install any new software, what you will do, you will put a checkpoint or save point. So when the system crashes, what you do, you can fetch all the data from that save point. Load balancing, we have already seen this concept in cluster. Load balancing is nothing but distributing the load equally. Collision resolution is nothing but if a collision occurs, collision in the sense failure occurs, you must be in a position to recover the data from that failure. So what now we are going to see the advantages and disadvantages of grid computing. So grid computing is used to solve larger, more complex problem in a shorter time. Next, grid computing is used to collaborate easier with other organizations, and it is used to make use of better hardware. Grid computing makes use of better hardware. The disadvantage of grid computing is grid computing softwares are still evolving. We are still in a developing stage and learning curve to get started. No interaction of job submission. So next we are moving to next concept called cloud computing. So in cloud computing, computing paradigm where computing is moved away from personal computers to a individual application server called cloud. So we have cloud is nothing but pay as you use. Cloud main concept is nothing but pay as you use. Pay as you use means like normal our electricity bill. So how much ever you use the electricity, you will pay. So you have different types of services in cloud computing, namely software as a service, infrastructure as a service, software as a service, SaaS, software as a service means SaaS, infrastructure as a service means IaaS, PaaS, platform as a service. So cloud computing basic thing is use as you use, pay as you use. So software as a service means you're having a system installed with Windows OS for specifying for testing your software engineer. You are going to develop a software in you develop a software in Windows OS. You need to test it in a sorry, we'll go in reverse because Windows is costly, whereas Ubuntu Linux is easy. So, or we'll go to Mac OS. So, you need to test your software in Mac OS. So, for testing, you cannot get the entire Mac OS, which is waste of time. So, what you do is you rent that Apple Mac OS for a particular period of time, say 10 days or 12 days. So after testing, if the software executes fine, you will release you will pay the cost only for 10 days. Whereas if you get the OS for 1 year, it will be very costly. You can split it and get it for 10 days. So such type is called. So that is called cloud computing, which is used for pay as you use. So abstraction is nothing but users cloud only need consent with computing service being asked for underlying details, how archives are hidden. Abstraction is similar to that in Java, data abstraction. Virtualization is nothing but cloud computing virtualizes system by pooling and sharing resources. So these are the benefits of cloud computing. So what you're going to see in this definition of cloud computing. So in this definition of cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. So example for computing resources are network servers, storage, application servers, that can rapidly provision and realized with minimal management effort or service provided interactions. So this is the next definition of cloud computing. So I repeat, next definition of cloud computing is nothing but a model for enabling ubiquitous, convenient, on-demand networks access to share a pool of configurable computing resources. So computing resources in the sense networks, servers, storage, application and services. So network, server, storage, application, each serves as a service that can be rapidly provisioned and released with minimal management effort or service provider interactions. So what are the characteristics of cloud computing? On-demand self-service, broad networks access, resource pooling, rapid elasticity, and measure service. So next we are going to see what is on-demand self-service. So on-demand self-service means user to provide and manage their own computing resources without human interaction. So on-demand self-service means it is a characteristics of cloud computing that allows user to provide and manage their own computing resources without requiring human interaction. So how this is achieved? This is achieved by provisional resources, managed resources, and scalable resources. So provision resources means automatically provision and deprovision computing resources, automatically commissioning and decommissioning provision resources such as servers, storage, and networks as needed. And how we are going to manage resources is managers manage their own computing resources like configuring, monitoring, and troubleshooting without requiring IT support. And how we are going to scale those resources is you are going to scale up and scale down based on the matching business needs without having a purchase of new hardware. Without purchasing a new hardware, you're going to scale up or scale up the services. So what are the benefits of on-demand self-services? increasing agility, improved efficiency, reduced cost, and enhanced user experience. So all these are advantage of on-demand services. So examples are on-demand services or AWS. AWS is nothing but Amazon Web Service, Microsoft Azure, Google Cloud Platform, and VPS. VPS is nothing but virtual private servers, which allows on-demand capabilities. Next, SaaS. SaaS means software as a service. So all these are examples of on-demand services. Next, we are moving to broad network access in cloud computing. So broad network access in cloud computing refers to ability to access the network or cloud computing service from anywhere. So it is nothing but ability to access the cloud service anywhere at any point of time using any device with an internet connection. With the internet connection, you can access any device at any point of time. So there are two types: multiple location, multiple devices, and multiple platforms. So multiple locations means user can access network or service from different location, such as office, home, coffee shops. Multiple devices means user can access the network or service using different devices, such as desktop, laptop, tablets, etc. Tablets, smartphones, smartwatch. From anywhere they can access. Multiple platform in the sense user can access the network using different operating system, such as Windows, Mac OS, iOS, or Android. So what are now moving to benefits of broad access network? So what are the main benefits is it is increased flexibility, improved collaboration, enhanced mobility, and reduced cost. So if you see every points in detail, increased flexibility in the sense increased flexibility in the sense broad network access, which enable access to work from anywhere at any time. Improved collaboration in the sense broad network access, which enables team collaboration regardless of location or devices. Enhanced mobility is broad network access to network, which goes to enhance mobility and responsiveness. Reduced cost is nothing but broad network access can uh, reduce cost by eliminating the need of dedicated network and infrastructure resources. So now we are going to see characteristics of broad network access. First characteristics is device independability. Since the devices are connected to network, you can access any device anywhere at any point of time. Platform independent. Network can be accessed in any platform in the sense any OS. Scalability in the sense network service can scalable to meet large user demands. So to manage large user demands, scalability comes to. So broad network access example is mobile networks such as 4G 5G. So provide broad network access. VPNs, virtual private networks, to private enable user access to access network at any point of time. So this is the use, benefits, and types of broad network access. Now we are moving to next topic, which is nothing but resource pooling. So resource pooling means pooling of resources such as computing power, storage, networking to provide multi-tenant environment. Resource pooling is used to provide multi-tenant environment. So this allows multiple user organization to share the same physical resources. So multiple users can share the same physical resources and access it from anywhere at any point of time. So what are the benefits of resource pooling? Resource pooling is used for increased efficiency. Increased efficiency in the sense resource pooling enable multiple users to share same resources at the same time. Scalability, resource pooling allows for rapid scaling up and down to meet the changing business demand. and it is cost saving. Cost saving in the sense it will reduce the cost. Individual users, organization to maintain their own resources, improved reliability. Resource pooling can provide improved reliability by easily upgrading or downgrading the resources. So types of resource pooling: compute resource pooling, storage resource pooling, network resource pooling. Compute resource pooling means pooling of computer resources such as CPU and memory. So such that is called as compute resource pooling. Storage resource pooling is nothing but pooling of storage devices such as disk space and data storage. Network resource pooling is nothing but pooling of network resource such as bandwidth and network connectivity. So what are the, now we are going to see the characteristics of resource pooling. So resource pooling, you have multi-tenancy. So multi-tenancy means multi-users or organizations share the same physical resources. Next, we are going to use dynamic allocation. Dynamic allocation means resources are allocated and deallocated dynamically only based on the demand. So, based on the demand, resources are dynamically allocated. Virtualization. Virtualization means resources are virtualized to provide a layer of abstraction between physical resources and the users. So, the example of resource pooling is nothing but grid computers, virtualized data centers. Virtualized data centers are nothing but the resource pooling used to provide infrastructure for multiple users across various organizations. So this is resource pooling. So next, fourth topic in characteristics of cloud computing is rapid elasticity. Rapid elasticity in cloud computing is refers to how quickly scale up and scale down the changing business demand. This means computing power, storage, and networking can be rapidly provisioned and deprovisioned to perform the matching demand. So, what are the benefits of rapid elasticity? Is increased agility. So, increased agility in the sense enables business to quickly respond to the changing market conditions. Improved scalability. So, improved scalability allows business to scale up or scale down without having purchase or provision of a new hardware. Reduced cost. Rapid elasticity enables business to only pay the resources one and only required. When they need the item, they will use reduced cost. Enhanced flexibility. So it provides business with the flexibility to quickly experiment with new ideas and applications without having to worry about underlying infrastructure. However, the infrastructure will be, if you have a network, you can scale up, scale down, increase or decrease the demands based on the need. So what are the characteristics? All these same characteristics: on demand self-service, automated scaling, dynamic allocation, multiple tenancy. Multiple tenancy in the sense cloud resources can be shared among multiple users, which enable rapid elasticity and scalability. So examples of rapid scalability is used in e-commerce platform, online gaming platform, online e-commerce platform, cloud computing providers. So cloud computing providers are nothing but Amazon Web Service, Azure. So all this use rapid elasticity. So what are the best practice to use rapid elasticity is using cloud native application. Cloud native application are designed to take the advantage of using rapid elasticity and scalability. Implemented in automated scaling. Implemented automatic scaling is used to dynamically allocate and deallocated resources based on the changing demand. Use containerization. Containerization is used to enable rapid deployment and changing of application. Monitor and optimize cloud resources utilization to ensure the resources and minimize the waste. So for all this, you will use rapid elasticity. Next, last characteristics of cloud computing is measured service. So as the name implies, the key characteristics that refers to the ability to measure and build the cloud resources based on the actual usage. So based on the actual usage, you need to build the customer. Then only you can increase the customer. So this means that cloud providers can track and measure the use of their resources and services and bill customer accordingly. So benefits of measured customer is pay as you go pricing. First thing is pay as you go pricing. Pay as you go pricing means customers only pay for what resources they have actually used. Next, increased transparency. Increased transparency is measured service provide cloud resources usage and cost, enabling customers to better manage their budgets and optimize their usage. Improved cost control. Improved cost control is measured service enable customers to control their costs by only paying for the resources and services they need. Enhanced scalability. Enhanced scalability is nothing but measured service enable customers to quickly scale up or scale down, meeting changing demands without having to worry about the fixed cost or contract. So characteristics of measured service, first characteristics is usage based billing. So when you go to usage based billing, cloud providers will provide bill to the customer based on the actual usage of the resources and services. So customers are billed only for the resources and services they have used. Real-time metering. Real-time metering is cloud providers track and measures the resources usage in real time, which enables them to provide accurate billing and cost control. Granular reporting. Granular reporting means cloud providers provide analytics to help customer to understand how they are using the resources and optimize the cost. Because you have heard of it, I hope. In AWS, if you have started one bucket and if it keeps on running, large amount will be waste. Large amount will be large of amount will be costed. So granular reporting will enable user to understand how much what service they are using, how much cost it has been will be billed. So with that help of granular reporting will be like graphs. So based on the usage, you will be costed. Automated billing. So automated billing in the sense cloud providers provide automatic billing process which involves to eliminate manual invoicing and payment processing. Automatic involvement means automatically bill will be generated from the bill. If you click payment, it will be moved to some payment platform such as Billdesk, Paytm, or any credit card using credit card, debit card you pay. So from that, all the after bill payment, email message will be triggered both to customer and also to the cloud provider who is providing the service. So example of cloud professional service, SAS software as a service, such as so example of SAS is Salesforce, Dropbox. So often they go for pay as you go pricing. Platform as a service, such as Heroku, Google App Engine, often go for pay as you go pricing platform. So best platform, best services practices to implement measured practices, usage based billing, real time metering, granular reporting, and automatic billing. So these are used for measuring the measured services. So cloud computing components, you will have clients, you will have data centers and internet. Sorry. So you have many layers, namely infrastructure layer, platform layer, application layer, deployment layer, service layer. So we will see each layer in detail. So infrastructure layer will have servers, storage and networking. Servers is used to provide computing power and storage. Storage provides data storage and management. Networking layer will enables communication between devices and services. So all this server, storage and networking will be in infrastructure layer. So next to platform layer. Platform layer will have operating system, which is used to manage and allocate resources. Middleware will enable communication between application and infrastructure. Runtime environment provide a platform for application to run. So application layer, as discussed, it will have SaaS or PaaS, software as a service or platform as a service. Software provides software application over internet, and PaaS provide platform for deploying and developing application. Deployment layer will have public cloud, private cloud and hybrid cloud. Public cloud is nothing but a cloud computing environment open to all general public. So all general public could use this cloud. Private cloud single organization. If a single organization is used to resources share and generate resources, you will use private cloud. Hybrid cloud, which is nothing but a combination of public and private cloud. So what are the main key components of cloud computing is virtualization, containerization, cloud storage, cloud networking, cloud security, cloud management, scalability and high availability. So we'll see each and every points in detail. What is virtualization? Virtualization is nothing but enable virtual machines to run on a single physical server. So that is called as multiple virtual machines to run on a single physical server. So that is called as virtualization. Containerization enable multiple application to run on a single server or virtual machine. So if multiple application run on a single server or it is called as containerization. Cloud storage provide scalable and on-demand storage for data. Cloud networking. So cloud networking is used to enable communication between devices and servers in the cloud. Cloud security provide measures to protect data and applications in the cloud. So cloud security is used to provide security to all the services used by the users. Cloud management. So cloud management is used to provide tools to manage and monitor the cloud resources. Scalability will enable cloud resources which is to be scaled up or scaled down based on the meeting demands. And high availability ensure that cloud resources are available and accessible all over the time. So far we have seen all the characteristics. So benefits of cloud computing is lower cost, obviously lower computer cost, reduced server cost. By using cloud infrastructure pay as you demand, you can save capital and operational investment. Ease of utilization, quality of